Good evening. Good evening. Welcome for today's session. If my audio and video is clear, I request the participants to just raise the hand. If audio and video is clear, I request the participants to just raise the hand so that we can start our discussion for today. So if audio and video is clear, I request the participants to just raise the hand so that we can start our discussion for today. Correct. Thank you. So in the last class, we are discussing about protection of alternator. So in the protection of alternator, as I said, I will discuss these topics: protection of alternator. So whenever you are saying you are analyzing the protection of alternator, we need to just a minute. We need to go analyze, like, the alternator consists of what? Stator protection. Stator is to be protected, and rotor is also to be protected. Okay. The starter of the alternator consists of three-phase windings. So the starter winding is to be protected from short circuit fault, is to be protected from short circuit fault, and interturn fault also. Interturn fault. And we should also protect the rotor winding, which has been excited with a separate DC source. As you know, in alternators, in machines you'll be studying, the field winding is excited with a separate DC source. So we need to discuss about starter winding protection and rotor winding protection. In starter winding protection, that is regarding the short circuit fault protection we have completed in the last class. Okay. Now we need to go for interturn fault protection and rotor winding protection. And we should also discuss about protection from abnormal conditions. Abnormal conditions. How the alternator is to be protected from these abnormal conditions, that is to be discussed here. So what are the abnormal conditions that the alternator may experience, that I have said? So the alternator is to be protected from abnormal conditions such as unbalanced loading, unbalanced loading, overloading protection we need to discuss, overloading protection, and overspeed protection we need to discuss, loss of excitation, and loss of primary input, loss of primary input or mechanical input. We need to discuss the protection of all these aspects. So this topic we have already completed in the last class, that is the short circuit fault protection we have completed in the last class. So how the starter winding of alternator is protected from short circuit faults? Any idea? So that we have discussed in the last class. The short circuit fault protection of alternator, that is done by what? Percentage differential relay. We will be using percentage differential relay to implement the protection of starter winding of alternator from what? Short circuit faults. And we have also discussed the numericals. Yes or no? In the last class we have discussed the numericals also based on the protection of starter winding of alternator. Now let us discuss all this. Now coming to the interturn fault protection. Now coming to the interturn fault protection of starter winding. Interturn fault, interturn turn fault protection of stator winding of alternator. Stator winding of alternator. So how the interturn fault is to be sensed? Suppose if you observe here, you can't sense interturn fault by using a differential relay, because if you compare the currents on both sides by connecting the CTs, if interturn fault takes place, that means interturn fault means some of the turns of the same phase winding installation gets failed, then it is treated as interturn fault. So even the interturn fault is taking place, the current through both the CTs will be same. The current through both the CTs will be same. So interturn fault cannot be sensed by using differential protection. Interturn fault cannot be sensed by what? Using differential protection, we can go for interturn fault. Okay. Now how to get the interturn fault protection then? How can we go for interturn fault protection? That depends on the number of windings per phase. The implementation of interturn fault protection depends on number of windings per phase. Number of windings per phase. So if you observe the alternator winding, if you observe the alternator winding that you will be studying in machines, sir. That you will be studying in machines. So the stator winding of alternator, stator winding of alternator may consist of first one, that is more than one winding per phase. There are two types of windings construction, that is more than one winding per phase, that is known as multi-phase winding. More than one winding per phase, one winding per phase, that is known as multi-phase winding. Okay, multi-phase winding. And the second configuration is only one winding per phase, only one winding per phase, only one winding per phase. So the stator of the alternator, the stator winding of the alternator may be of these two configurations. One is more than one winding per phase, and the other one is only one winding per phase. So how the multi-phase winding protection can be given, and how if there is only one winding per phase, how the protection can be given, that we need to analyze here. So if the stator of the alternator consists of more than one winding per phase, more than one winding per phase, we will be using split phase differential relay. Here we will be using what? Split phase differential relay. Differential relay. Split phase differential relay is used. Split phase differential relay is used for protection of stator winding of alternator from interturn faults if the stator of the alternator consists of more than one winding per phase. If the stator of the alternator consists of what? More than one winding per phase. If there is only one winding per phase, if there is only one winding per phase, how the stator of the alternator is to be protected? How do you protect the stator winding of alternator? By using watt hour relay. Here what do you use? Sorry, just a minute. By using watt hour relay, we will protect the stator winding of alternator in case of what? The stator of the alternator consists of only one winding per phase. Now let us see how the multi-phase winding is protected. Okay, how the split phase differential relay is split phase differential relay differential relay is implemented for protection of stator winding of alternator from interturn faults. Now let us observe. Suppose if the each phase, that is R phase, Y phase and B phase, consists of more than one winding per phase, more than one winding per phase. This is R phase and Y phase and B phase. So if the stator of the alternator consists of more than one winding per phase, how we can implement the interturn fault protection, that you need to observe. So this is R1, R2. There are two windings per phase, and this is Y1, Y2, and this is B1, B1, B2. Okay. Now here what you will do, in case of split phase differential relay, what you will do, we will compare the currents on the same phase windings. We will compare the currents on the same phase windings. So here the current of R1 is compared with R2 by connecting the CTs. So how do you connect the CTs? These CTs are connected in differential mode. The CTs are connected in differential mode. The CTs are connected in differential mode here. Okay. Now here in this differential mode we need to connect the relay coil. Okay, relay coil, CTs are connected in differential mode, and in the differential mode relay coil is connected. So if there is no interturn fault, the currents through the two coils R1 and R2 will be same, because number of turns per phase will be same. R1 and R2 number of turns will be same, so in CT1 and CT2 currents will be same, so difference of the currents will be zero, so the relay will not operate. There will not be any current to the relay coil and the relay will not operate. On the same lines, in case of Y1 and Y2 also, the two CTs will be connected in differential mode, and this in this differential mode relay coil will be connected. Here that is known as what? Split phase differential relay. This is known as what? Split phase differential relay. It can be used for protection of stator winding of alternator from interturn faults. Now let us observe what happens if the fault takes place. What happens if the fault takes place? Suppose if Y1 turns got experiencing Y1 is experiencing interturn faults. Y1 is experiencing interturn faults. When Y1 is experiencing interturn fault here, the number of turns in Y1 and Y2 will not be same, because some of the turns insulation got failed. Some of the turns insulation got failed in Y1. So Y1 and Y2 are not having effective same number of turns. So what happens? Induced EMF will not be same. So the current in this Y1 and Y2 will not be same. The current in this Y1 and Y2 will not be same. The difference of the currents will be through the relay coil and the relay will operate. The difference of the currents will be through relay coil and the relay will operate. This is known as what? Split phase differential relay. So where do you use split phase differential relay? In protection of alternator, if the stator of the alternator consists of more than one winding per phase. If the stator of the alternator consists of more than one winding per phase, that is multi-phase winding, we'll be using split phase differential relay. If the stator consists of only one winding per phase, we'll be using what? Watt-hour relay. Okay. Understood my point here? This is the split phase differential relay construction. So in case of split phase differential relay, in case of split phase split phase differential relay, CTs are connected in differential mode, in differential mode. So CTs are connected in differential mode. So during during normal condition normal condition, the currents in respective phase respective phase will be equal, and no current flows through relay coil. No current flows through relay coil. Flows through relay coil. But when interturn fault takes place, what happens? When interturn fault takes place, when interturn when interturn fault takes place, when interturn fault takes place, the effective number of turns will not be same. The effective number of turns will not be same. So induced EMF, induced voltage, we can say voltage will be different. So current delivered will not be same. The difference of the currents will be through relay coil. There will be current through relay coil, and relay operates. Okay, this is nothing but a split phase differential relay operation. So split phase differential relay where to use in protection of alternator from what? Interturn faults. In protection of alternator from interturn faults. So when there is no here, what you are connecting here? You are connecting the CTs in differential mode. Here we are connecting the CTs in differential mode. CT1, CT2 is connected in differential mode. That's what the first point I have done. So and during normal condition, the induced voltage in E1, R1 and R2 will be same. So the current delivered by R1 and R2 will be same. So difference of the currents is zero, the relay will not operate. So during normal, second point is during normal condition, the currents in respective phase will be equal, no current flows through the relay coil. And when interturn fault takes place, what happens? The effective number of turns will not be same. The difference of the currents will be through the relay coil and the relay will operate. Okay. This is how a split phase differential relay can be implemented. So this is possible only if there are more than one windings per phase. That is in case of multi-phase winding only, that is possible. That is in multi-phase winding only we can implement this interturn fault protection. In multi-phase winding only we can implement what? Interturn fault protection. But if there is only one winding per phase, so what happens if there is only one winding per phase? What type of relay we should use? Here we should use what? Watt hour relay. We should use what? Watt hour relay for protection if there is only one winding per phase. So now let us go for watt hour relay. Okay, watt hour relay. So watt hour relay, when do you use? For protection of starter winding of alternator from interturn fault if there is only one winding per phase. That means if the R phase has only one winding, Y phase has only one winding, and B phase has only one winding per phase, then you will be using watt hour relay. So this is only one winding per phase, you can implement this. So generally the neutral of the alternator is resistance grounded to improve the transient state stability. Okay. Now as you know, the watt hour relay consists of current coils as well as voltage coils. Voltage coils. To give, now let us see how this watt hour relay can be implemented for protection of starter winding from interturn fault. Okay. So to excite the voltage coils and current coils of the watt hour relay, we'll be using an auxiliary transformer, auxiliary three winding transformer. The primary of the auxiliary transformer, this is the primary of the auxiliary transformer. Primary of the auxiliary transformer will be star connected, and it is excited by the alternator output itself. And it is excited by what? Alternator output itself. And what about the secondary? The secondary is also star connected. The secondary is also star connected, and it is left open. Secondary of the auxiliary transformer is also star connected and is left open. And the tertiary is delta connected, and it is open in one of the phase. Okay, tertiary is delta connected and it is open in one of the phase. Now you observe the watt hour relay consists of two coils. One is voltage coil and the other one is current coil. So the three phase system. So we will use what? Three voltage coils. This is the voltage coils of three phase system. One voltage coil is connected between R and Y. The second voltage coil is connected between Y and B. The third voltage coil is connected between B and R. Okay. So the voltage coils of the watt hour relay. Now what about the current coils? The current coils, how do you connect? The current coils of the watt hour relay, all are connected in series. All the three coils of the current coils of the watt hour relay are connected in series. And these current coils are placed in the tertiary winding. These current coils are placed in the tertiary winding. Okay. This is a watt hour relay. Watt hour relay. So this is how a watt hour relay is to be operated. Now let us observe how this watt hour relay will sense the interturn fault. Now the question is how this watt hour relay will sense the interturn fault. So whenever there is no fault, when there is no fault during normal condition, the voltages that are induced in R phase, Y phase, and B phase during normal condition, the voltages that are induced in R phase, Y phase, and B phase are balanced or unbalanced. Balanced. During normal condition, the voltages that are induced in R phase, Y phase, and B phase are balanced. So as they are balanced, there will be only fundamental frequency, that is 50 hertz frequency of voltage induced in the three phase windings. The same 50 hertz frequency voltage will be induced in primary, secondary, and tertiary. So the voltages are balanced. Will there be any circulating currents in the tertiary winding? If the voltages are balanced, will there be any circulating currents? Whenever the voltages are balanced, there will not be any circulating currents. When the voltages are balanced, there will not be any circulating currents. So once there is no current, what is the operating force expression of the watt hour relay? K1 VI cos of phi minus tau. So when there is no current, operating force is zero, the relay will not operate. The relay will not operate. Now let us observe what happens when interturn fault takes place. Suppose if this Y phase is experiencing interturn fault. Suppose Y phase is experiencing interturn fault. So due to interturn fault, what happens? The supply voltage waveform gets distorted. Here there will be distortion in voltage waveform, So the supply voltage gets distorted, and it consists of harmonics, Okay, the supply waveform is distorted, and it consists of harmonic content. Understood my point? The supply voltage waveform is distorted, and it consists of harmonic contents. The same harmonic voltage will be induced in primary, secondary, and tertiary. The same harmonic voltage will be induced in primary, tertiary, and secondary. Okay, understood my point? So due to this harmonic induced voltages, there will be circulating currents in the currents in the tertiary winding. There will be circulating currents in the tertiary winding. Okay, and the relay will operate. Okay, as you know, the delta circuit offers closed path for what? Delta circuit offers closed path for harmonic currents. Those harmonic currents will be circulated in the tertiary winding, so current coils will be excited and voltage coils are always excited, so the relay will operate. So this is how watt hour relay can be used for sensing interturn faults. Whenever there is only one winding per phase, whenever the stator of the alternator consists of only one winding per phase. Okay, so how you can write this way? So how you can make a note of this? If the stator of the alternator, if stator of alternator consists of only one winding per phase, only one winding per phase. If the stator of the alternator consists of only one winding per phase, interturn fault protection is done by what? Interturn fault protection is done by is done by watt hour relay. Okay, watt hour relay. Understood my point? So the voltage coils and current coils, how you are exciting? By using an auxiliary transformer. So the voltage coils and current coils of the watt hour relay are excited by auxiliary transformer. The voltage coils, comma, current coils of auxiliary transformer are excited by voltage coils and current coils of watt hour relay. This is not auxiliary transformer of watt hour relay are excited by auxiliary transformer of watt hour relay are excited by auxiliary transformer. Okay, so this is how the construction is done. And during normal condition, the voltages are balanced, so there will be no current. But whenever interturn fault takes place, what happens? There will be harmonic voltage induced in that phase. That phase voltage will be also consisting of harmonic induced voltage in all the three phase windings of the transformer, that will result in current through the coil. Okay, so during normal condition, during normal condition, what happens? The voltages are balanced. Voltages are balanced and consists of 50 hertz component, fundamental component only. So there will be no current and relay will not operate. So there will be no current and relay will not operate, and relay will not operate. Okay. Now what happens when interturn fault takes place? What happens when interturn fault takes place? When interturn fault takes place, there will be harmonic induced voltage. There will be harmonic induced voltage, which results in relay operation, which results in relay operation. So because whenever the interturn fault takes place, harmonic voltages are induced in primary, secondary and tertiary. Tertiary is a closed path. No, this tertiary winding is closed path. It will drive the currents to the current coils and the relay will operate. So this is how interturn fault protection is done. Interturn fault protection is done in case of watt-hour relay. In case of watt-hour relay. Now let us observe here. So in the last class I have completed this short circuit fault protection. Now I am going to this interturn fault protection of starter winding. So interturn fault protection of starter winding depends on the number of windings per phase. The number of windings per phase. If the starter of the alternator consists of more than one winding per phase, that is known as what? Multi-phase winding. In case of multi-phase winding, we'll use what? A split phase differential relay. In case of multi-phase winding, we'll use what? A split phase differential relay. And if the starter of the alternator consists of only one winding per phase, we'll be using what? Watt-hour relay. Okay. Now, split phase differential relay, what you will do? In split phase differential relay, what you will do? We will compare the currents on the same phase by connecting the CTC in differential mode. So we will compare the currents on the same phase by connecting the CTC in a differential mode. So during normal condition, the voltage induced in R1 and R2 will be same or different? Same. So the current delivered will be also same. So that will not result in any current to the relay coil. So relay will not operate. But when interturn fault takes place, the effective number of turns will not be same. That will result in induced voltage will not be same. So that will result in different currents. The difference of the currents will be through the relay coil. I1 minus I2 will be through the relay coil, and the relay will operate for interturn fault. So when do you use this split phase differential relay? In case of multi-phase winding. Okay. In multi-phase winding, we will be using split phase differential relay. Now, whenever the starter of the alternator consists of only one winding per phase, here you cannot compare because there is only one winding. That's why we will use what? Watt-hour relay. For sensing that interturn fault. Okay. So that is about interturn fault protection. Now let us analyze the protection of alternator from abnormal conditions. What will use? Protection of alternator. The protection of alternator from abnormal conditions. How do you protect the alternator from abnormal conditions? Now let us observe. Okay, I have given different abnormal conditions. First one is unbalanced loading. How do you sense the unbalanced loading on the alternator? So what is the difference between balanced loading and unbalanced loading? What is the difference between balanced loading and unbalanced loading? That you need to understand first. Okay. So whenever the loading is balanced, what do you have? And whenever the loading is unbalanced, what do you have? Whenever the loading is balanced, what do you have? Whenever the loading is unbalanced, what do you have? Whenever the loading is balanced, there will be only positive sequence currents. That means only IR1. That is positive sequence currents only exist. Only positive sequence positive sequence currents exist. Only positive sequence currents exist during what? Balanced condition. Whenever the loading becomes unbalanced, there will be positive sequence currents and negative sequence currents. Both positive sequence and negative sequence exist. Both positive sequence currents as well as negative sequence current exist when, sir? Whenever the loading is unbalanced. Whenever the loading is balanced, there will be only positive sequence currents, and whenever the loading is unbalanced, there will be both positive sequence currents and negative sequence currents. Understood? So what is the observation that you have done here? What is our observations are? We have observed that unbalanced loading can be sensed by using negative sequence currents or not. If you can sense this negative sequence currents, the problem is solved. So what is our observation? Unbalanced loading can be sensed by unbalanced loading. Unbalanced loading can be sensed by using negative sequence relay. So unbalanced loading can be sensed by what? Using negative sequence relay, because unbalanced condition only negative sequence currents are coming into picture. Okay. Now how do you construct this unbalanced negative sequence relay? Suppose if you consider the stator winding of alternator, this is R phase, Y phase and B phase, R, Y and B. The neutral of the alternator, generally it is resistance grounded to improve the transient stability, we can say. Now, so here we will be using for construction of the negative sequence relay, it can be implemented using a bridge type structure. Here we will be using a bridge type structure. During normal condition, the bridge is tuned to be in balanced state, and the inputs are given by connecting the CTs here. During normal condition, the bridge is tuned to be in balanced state, and the relay coil is connected in the middle. Okay, this is the relay coil which is connected in the middle. During normal condition, the bridge is balanced, so the relay will not operate. Instead of detector, what you will use here? Instead of detector, you will be using the relay coil. Instead of detector, we will be using what? Relay coil. So the relay will not operate during normal condition because the bridge is balanced. Whenever the bridge is unbalanced, whenever the loading is unbalanced, automatically the currents in the series will not be equal. So that the bridge balance will be disturbed, and that will be operated. So this is known as what? Negative sequence relay. Okay. So generally the time of operation of negative sequence relay is inversely proportional to square of the current. The time of operation of negative sequence relay is inversely proportional to what? Square of the current. Okay. So unbalanced loading. How do you sense the unbalanced loading? By using negative sequence relay. Why? Because balanced loading is resulting only in positive sequence currents. Balanced loading will result only in positive sequence currents, but unbalanced loading will result in both positive sequence currents and negative sequence currents. Sir, what do you mean by positive sequence currents? You may have a doubt. What do you mean by positive sequence currents and what do you mean by negative sequence currents? Suppose if you take IR, the three phase currents IR, IY and IB are equal in magnitude and phase displaced by 120 degrees, and the phase sequence is same as what? Original phase sequence of the network. Then they are known as positive sequence currents. So if the magnitudes are equal and phase displaced by 120 degrees, and the phase sequence of these components of currents are same as original phase sequence of the network, they are known as what? Positive sequence components. Now what do you mean by negative sequence components, sir? Here negative sequence components are also equal in magnitude, IR, IY, IB. are also equal in magnitude. But here, if you observe, the phase sequence is reversed. The phase sequence is reversed. So IR2, IY2, and IB2. Okay, the phase sequence is reversed. So they are known as negative sequence components. So whenever the loading is balanced, there will be only positive sequence currents. But whenever the loading is unbalanced, there will be positive sequence and negative sequence currents. So this unbalanced loading can be sensed by using a negative sequence relay. Unbalanced loading can be sensed by using a negative sequence relay. Here time of operation is inversely proportional to what? Square of the current. Understood my point? Okay. Now let us go for the next abnormal condition, that is overloading. Overloading. Overloading means what? Overloading means what? So this is not a fault condition, sir. Overloading means what? This is not a fault condition. What is this? This is an abnormal condition. This is an abnormal condition. Fault is different. Fault will result in overcurrent. Here there is no fault, but the quantity is exceeding its value. Exceeding its value. So now, what do you mean by overloading? What do you mean by overloading? Even when there is no fault, if the current to the starter winding may be more than its rated current, even when there is no fault, if the current to the starter winding may be more than its rated value due to overloading. Okay, so even when there is no fault, there is no fault, the current through starter winding maybe more than maybe more than its rated current due to overloading. Due to overloading. Okay. Due to overloading, it may result in that. Now, how do you protect the alternator from overloading? What is the effect of overloading? So whenever the current is more than its rated current, what about the heat generated by the conductor? That is I square R. So excessive heat generation will take place. So overheating of the winding will result. Overheating will take place. So how do you sense overloading? How do you sense overloading? Can you allow overload? So what happens? Excessive heating is generating. That is resulting melting of the winding or melting of insulation and damage of insulation. That's why to avoid that, what you'll do, this overloading can be censored by using overcurrent relay plus temperature sensing device. Temperature sensing device. Okay. Overcurrent relay can be overloading can be sensed by what? Using an overcurrent relay along with what? Temperature sensing device. For sensing overloading, we'll use overcurrent relay along with temperature sensing devices. Okay. What are the temperature sensing devices? Here you may use thermocouple or bimetallic strip. Bimetallic strip. Okay. This is about overloading. Okay. We have discussed about unbalanced loading, and the next one is overloading. Now, let us go for the third one, that is overspeed. Overspeed. Why the overspeed will take place? Why the alternator may experience overspeed? Any idea why the alternator may experience overspeed? Why the alternator may experience overspeed? Any idea, sir? Alternator will experience overspeed due to sudden loss of load. Alternator may experience overspeed due to what? Sudden loss of load. Whenever the load is suddenly reduced, it will result in what? Overspeed. Similarly, if you are driving your bike with two persons sitting on the bike, suppose if the person who is sitting on backside suddenly jumped, load has been reduced. What happens? Your bike speed increases. Okay, overspeed it is due to what? It may be due to sudden loss of load. It may be due to sudden loss of load. Sudden loss of load. So how do you sense the overspeed? How do you sense the overspeed? What happens whenever the speed increases? Induced voltage is directly proportional to what? Speed. Induced voltage is directly proportional to speed. Somehow is equal to 5Zn by 60 into P by A is equal to 5Zn by 60 into P by A. Induced voltage directly proportional to speed. So induced voltage is directly proportional to speed or not? If the speed increases, voltage also increases. So what is our observation? Here overspeed can be sensed by what? Using an over voltage relay. Okay, overspeed, overspeed can be sensed, can be sensed by using an over voltage relay. An over voltage relay. Overspeed can be sensed by using an over voltage relay. So generally the set value of this over voltage relay will be 110 to 120% of its rated current. Okay, set value of over voltage relay, over voltage relay, over voltage relay will be around 110 to 120% of rated voltage. 120 to 120% of rated voltage. Okay. This is a transient condition or steady state condition. Sudden loss of load is a transient condition. Sudden loss of load is a transient condition. So it may give the variation around 140 to 150% of overspeed. Okay, your over voltage rated is 110 to 120%, but it is a transient, sudden change. That's why it's give variation around 140 to 150% of overspeed. So as it is a transient condition, it may give around, it may give variation variation around 110 to 120% of, sorry, it may give around one variation of 140 to 150% of overspeed. You may think it is directly proportional, but this is a transient condition, so it goes around 140 to 150% of overspeed. Now, let us go for the next abnormal condition. Now, let us go for the next abnormal condition after completion of this overspeed. What is the next abnormal condition? Loss of mechanical input or primary input. Okay, loss of primary input, primary input or mechanical input also we can say. Loss of mechanical input or primary input also we can say. So if you observe alternator, if you observe alternator, alternator is a doubly excited machine or a singly excited machine? Alternator is doubly excited machine or singly excited machine? Doubly excited machine, because the field winding of the alternator is excited with what? A separate DC source. There will be a separate DC source. Due to this DC excitation, it will establish the flux. So it is a doubly excited machine. And this field winding is being rotated with the help of external mechanical input. And whenever this flux cuts, there will be an induced voltage. Due to mechanical input, the rotor is being rotated, and it will generate both real power and reactive power, and it is being delivered to what? Grid. So initially the alternator is delivering both real power as well as reactive power to grid. It is delivering both real power and reactive power to grid. This is during what? Normal condition. This is during normal condition. Now what is happening? Loss of primary input is taking. Loss of primary input is taking place. Loss of primary input means mechanical input got lost. This mechanical input got lost. So when the mechanical input is lost, what happens? Alternator field winding is excited. So it draws the real power from grid. And delivers the reactive power to grid, and behaves as a synchronous motor. Okay. So whenever the mechanical input got lost, how the machine behaves? As a synchronous motor. So what is your observation here? Initially alternator alternator is delivering both real and reactive power to grid. Power to grid. Initially, the alternator is delivering both real and reactive power to grid. Okay, but when mechanical input gets failed, when mechanical input gets failed, it behaves as what? It behaves as synchronous motor. by drawing by drawing real power from grid and delivering reactive power to grid and delivering reactive power to grid reactive power to grid and delivering reactive power to grid. So it is drawing real power from grid and delivering reactive power to grid. So can you allow this operation of synchronous? Can you allow the operation of synchronous generator as synchronous motor? Can you allow the operation of synchronous generator as synchronous motor? No, sir. We cannot allow because here synchronous motor operation is taking place. Motor means what? Motor converts electrical input to mechanical output. Motor converts electrical input to mechanical output. Electrical input to mechanical output. What is the load here? What is the load? Load on the rotor shaft. On the rotor shaft, what is fitted? Turbine. Load on the rotor shaft is what? Turbine. Turbine is heavy load or light load, sir? Turbine is heavy load. Turbine is heavy load. Okay. So in order to rotate the turbine, the machine draws heavy current from the grid. The machine will draw heavy current from the grid. Okay, which will damage the starter winding of the alternator. Okay, to avoid that, we should place a relay here. We should place a relay. So which relay is to be used here? The question is which relay has to be used? Which relay has to be used here? We should use reverse power relay. Reverse power relay. We should use which relay, sir? Reverse power relay for sensing the loss of prime or input. Okay, loss of prime or input can be sensed by what? Using reverse power relay. Okay, loss of prime or input is sensed by using reverse power relay. Reverse power relay. What will be the set values of this relay? What will be the set values of the relay? It will have set value of it will have set value of 2% of rated power, 2% of P rated for turbine driven generators, for turbine driven generators, and 10% of rated power, 10% of P rated for diesel engines or other mechanisms. Okay, you will have diesel generators as well as turbine diesel combustion engines and turbine driven generators now. So in turbine driven generators, P rated is 2% of P rated will be a set value. If it is driven by diesel engines or any other mechanism, it will be around 10% of rated power. So observe here. So initially the alternator is delivering both real and reactive power to grid. Initially the alternator is delivering both real and reactive power to grid. But suddenly when the mechanical input got failed, then it draws the real power from the grid and it delivers the reactive power to the grid. Operates as what? Synchronous motor. Here we should not allow the synchronous motor operation. Here we should not allow the synchronous motor operation. Why you should not allow the synchronous motor operation? Why you should not allow the synchronous motor operation? Because what is the rotor? And rotor is mechanically coupled to what? Turbine. Rotor is mechanically coupled to turbine. Turbine is heavy load or light load? Turbine is heavy load or light load? Turbine is heavy load. Turbine is heavy load. So in order to rotate the turbine, machine will draw heavy current from the grid. Machine will draw heavy current from the grid and the machine may get damaged. To avoid that, we will use which relay? Reverse power relay. It will have a set value of 2% of rated power turbine driven generators and 10% of rated power for diesel engine generators. Okay. So this is about loss of primal input or loss of mechanical input also we can say. Okay. Now coming to the last abnormality, that is loss of excitation. Okay. Loss of excitation. Loss of excitation. So what happens if the excitation is lost? Now let us observe here the synchronous generator is doubly excited machine. The field winding is provided with a separate DC excitation. Whenever DC excitation is provided, it will establish the flux. And the mechanical input is provided and this rotor is being rotated here. And alternator is synchronized to what? Grid. Alternator is synchronized to grid. So initially, the alternator is delivering both the real power to grid Alternator is delivering both real power and reactive power to grid. Alternator is delivering both real power and reactive power to grid. Now, when the excitation got lost, that means whenever this excitation got lost, what happens? Whenever the excitation got lost, mechanical input is present. Mechanical input is present, but excitation is lost. What happens? It will deliver the real power to grid, but absorb the reactive power from grid. To maintain that flux, it will absorb the reactive power from grid and behaves as induction generator. And behaves as what? Induction generator. Understood my point? So when excitation fails, alternator or synchronous generator behaves as what? Induction generator. And behaves as induction generator. Okay. Now, what is the point that you can note here? When excitation gets failed, gets failed, it behaves as it behaves as induction generator. Induction generator. So how do you sense this induction? How do you sense the loss of excitation? How do you sense the loss of excitation? Now observe here. So if you plot the Rx characteristic of any relay, Rx characteristic of any relay. So in first quadrant, if you observe, real power and resistance is positive, reactance is positive. That means both are delivering. Real power is delivering and reactive power is also delivering. Both are positive in first quadrant. In second quadrant, real power is negative, reactive power is positive. That means it is absorbing real power and delivering reactive power. In third quadrant, both are negative. Both are absorbing. And in fourth quadrant, real power is positive, reactive power is negative. That means it is absorbing it is generating real power and absorbing reactive power. Now observe this loss of excitation. Real power is delivering, reactive power is absorbing. So it falls under what? Fourth quadrant. So here we'll be using a relay which is known as offset Moore relay. Here, what is the actual Moore relay characteristic? Actual Moore relay characteristic is circle passing through origin. But if you induce a negative DC value, it can shift it to the required position. So here we'll be using which relay? Offset Moore relay. What happens? During normal condition, the impedance point will be at this position. But whenever the loss of excitation takes place, it may fall under this operation and the relay will operate for the fault. Okay. So which relay is used for loss of excitation? Using an offset Moore relay. Okay. Loss of excitation. Loss of excitation can be sensed. Can be sensed by using offset Moore relay. Moore relay. Loss of excitation can be sensed by using an offset Moore relay. Okay. Now these are the abnormal conditions that the alternator may experience. I will explain once again. If you have any doubt, it will be cleared. Now observe here. What are the abnormal conditions that the alternator may experience? What are the abnormal conditions that the alternator may experience? Unbalanced loading. What is the difference between balanced loading and unbalanced loading? Balanced loading will have only positive sequence currents, but unbalanced loading will have both positive sequence and negative sequence currents. So what is our observation? Unbalanced loading can be sensed by using which relay? Negative sequence relay. So for sensing unbalanced loading, we will use a negative sequence relay. It can be constructed using the bridge type structure. It can be constructed using what? Bridge type structure. Okay. So overloading. Overloading results what? Overcurrent. It will result in excessive heat generation. So due to which winding may get damaged. To avoid that, overloading is sensed by what? Overloading is sensed by what? Using an overcurrent relay along with temperature sensing device. What are the temperature sensing devices? Thermocouple and a bimetallic strip. Okay. So overspeed. Overspeed is what? It may be due to sudden loss of load. Overspeed may be due to sudden loss of load. Okay. When overspeed takes place, overall voltage also increases. Yes or no? So overspeed can be sensed by using an over voltage relay. Generally, it will have a set value of 110 to 120% of rated voltage. 110 to 120% of rated voltage. As it is a transient condition or steady state condition, overspeed is a sudden loss of load. It is a transient condition. So it may give variation around 140 to 150% of over speed. Okay. So this is about over speed. Next one is loss of primor input. Loss of primor input or mechanical input also we can say. When the primor input got lost, what happens? The alternator behaves as synchronous motor. Okay. How do you sense this? By using a reverse power relay. By using which relay? Reverse power relay. It will have set value of 2% of rated power for turbine driven generators and 10% of rated power for diesel engines or any other. Okay. Loss of excitation. How do you sense the loss of excitation? By using which relay? We'll be using what? Offset more relay. Offset more relay. So alternator behaves as what? Induction generator. Whenever there is a loss of excitation takes place. So this is about protection of alternator from abnormal conditions. From abnormal conditions. How the rotor winding is to be protected? Rotor winding protection. Rotor winding protection. There is some special circuit used for this rotor winding protection. So if you observe, the field winding of the alternator is placed on what? Rotor. This is the field winding. Field winding is placed on the rotor and it is excited with a separate DC source. Here we will be using a separate DC generator to excite that source. Suppose this is plus and this is minus. So it will establish the flux. Separate DC excitation has been provided. Separate DC excitation has been provided. Separate DC excitation has been provided for this field winding because that's why it is known as what? A doubly excited machine. Alternator is known as doubly excited machine. So here to protect this field winding, we will use a special circuit. What you will do? Let this node be A. Let this node be A. Now here we will connect the relay with the series with resistance. There will be a resistance in series with a relay. Now we will develop a logic circuit like this. If the potential at node and potential at node A and node B are same, the relay should not operate. Yes or no? If potential at node A and potential at node B are same, then the relay will not operate. So for that, what you will do here? We will use a DC rectifier circuit here. Full bridge rectifier you will be using. We will use what? Full bridge rectifier circuit. Okay. And how do you construct? How? What are the inputs for this DC rectifier? AC value is required. No? So we will be exciting the AC source, and this is a DC rectifier circuit. And by using this DC rectifier, we will maintain initially the potential at node and A and B are same. Initially, VA equal to VB. But whenever this field winding experiences any fault, node A potential and node B potential will not be same. Node A potential and node B potential will not be same, and that will result in current through the relay. Current through the relay. Okay. So this is how rotor winding is being protected. What is the purpose of resistance here? Purpose of resistance. Purpose of resistance is to limit current through relay. Okay. Current through relay. To limit the current through relay, we are using this resistor in series with the relay. Understood my point? So this is about rotor winding protection and protection of alternator winding from any type of fault. From any type of fault we have discussed. We have discussed about stator protection. We have discussed about rotor winding protection and protection from abnormal conditions. Numericals are very important, sir. In the last class, we have discussed numericals, how to calculate the current to the relay operating coil, whether the relay operates or not, and what is the percentage of winding that has been protected, and what is the percentage of winding that has been protected. Okay. So this is all about alternator protection, sir. Now let us go for bus bar protection. Bus bar protection. How the bus bar is protected? Bus bar protection. How the bus bar is protected? Now let us observe here. Suppose if there is a transformer, this is transformer. Now to this HT side there will be a bus bar, and to this bus bar the feeders are being connected. Feeder 1, feeder 2, and feeder 3. Now how do you implement? How do you implement the how bus bar protection? How the bus bar is protected from short circuit fault? How the bus bar is to be protected from short circuit fault? That is the question. What you do, and while explaining differential relay only, I have said, while explaining differential relay only, I have said the bus bar is protected by using what? Percentage differential relay. Bus bar is protected using what? Percentage differential relay. So how do you implement percentage differential relay? What do you do? Here we will compare the transformer side current with the sum of the currents in the feeders. So whatever the current that is delivered by the transformer should be equal to the sum of the currents in the feeders or not. Here we are comparing the transformer side current with the sum of the currents in the feeders. Okay. So this is the bus bar that is to be protected. Now when short circuit fault takes place, what happens? This bus during normal condition, the current in the transformer side CT and some of the currents in the CTs which are connected on the feeders will be same. So there will be no current through the relay coil. But when when fault takes place on this bus bar, when short circuit fault takes place on this bus bar, what happens? There will be current circulated through this transformer side CT, but there will be no currents on the CTs which are connected in these feeders. That will result in current to the relay and the relay will operate. So the question may be asked like this: how the bus bar can be protected? How the bus bar can be protected? Bus bar can be protected by using what? Percentage differential relay. So bus bar is protected bus bar is protected using percentage differential relay. Percentage differential relay. Okay. by comparing by comparing transformer side currents with some of the currents in feeders, some of currents on feeders. So this is about bus bar protection. Now, while explaining differential relay, I have said, that we can compare either two currents or two voltages. Comparing two currents I have discussed. We can also compare two voltages. That is known as voltage balanced differential relay. Now let us discuss about voltage balanced differential relay. Differential relay. So what do you mean by voltage balanced differential relay? Now let us observe here. So here voltages are being compared. So what do you do here? The CT secondaries, the secondary side coils are connected in subtractive mode. Suppose there are two induced voltages, E1 and E2. So two coils are to be connected in subtractive mode. So whenever dotted terminal is connected to the dotted terminal, what that is nothing but subtractive mode connection. Okay. So during normal condition, the induced voltage E1 and E2 will be same or different. The induced voltages E1 and E2 will be same or different. During normal condition, when there is no fault, the current in the CT1 and CT2 will be same. So the induced voltage will be same or different. Induced voltage will be same. So when the voltages are same and they are connected in what? Subtractive mode. E1 and E2 are same and they are connected in subtractive mode. So what will be the current through the relays? Zero. Now observe here, two cells of 1.5 volts. 1.5 volts. They are connected in additive mode. Whenever they are connected in additive mode, current flows or not, I is not equal to 0. But if you connect in subtractive mode like this, negative terminal connected to negative terminal, and now when you short circuit this, current is 0 or not? Current is 0. So the relay will not operate during normal condition. During normal condition, you should get this operation, and during fault condition you should get this operation. During fault condition you should get the current to the relay. Okay. During normal condition, what operation is to be obtained? A subtractive mode. During a fault condition, additive mode should be analyzed. Okay. Now observe. So during normal condition, how the coils are connected? In subtractive mode the coils are connected. Okay. The secondary side coils, the secondary side coils are connected in a subtractive mode, subtractive mode. So E1 and E2 will be equal. E1, E2 are equal, and relay will not operate, and relay will not operate. But when fault takes place, E1 and E2 will not be same. That will result in current through the coil. When fault takes place, when fault when fault takes place, E1 and E2 are not same, are not same. Relay will not operate. Relay will not operate. Relay will not operate. Understood? This is how voltage balance differential relay will be operated. Because when fault takes place, what happens? E1 and E2 will not be equal. That will result in current to the relay, and the relay will operate. Now, where to use this? Where you can implement this voltage balance differential protection? Where you can implement this voltage balance differential protection? That is the option here. So this can be implemented in protection of EHV lines and distribution lines. Okay, it can be used. It can be used in protection of EHV lines, extra high voltage, EHV lines, and distribution lines, and distribution lines. EHV lines is extra high voltage lines and distribution line protection. Distribution is three phase or single phase? Distribution is three phase. So for one phase, you require how many pilot wires here? Pilot wires. How many pilot wires are required for one phase? Two pilot wires. For one phase, you require two pilot wires. So for three phase system, how many pilot wires are required? Six pilot wires are required. For each phase, you require how many pilot wires? Two pilot wires. So for a three phase system, you require how many pilot wires? Six pilot wires are required. So number of pilot wires requirement is more or less more. So for as distribution is three phase, as distribution is three phase, we require six pilot wires. Pilot wires. As distribution is three phase, we require six pilot wires. To reduce the number of pilot wires requirement, here to reduce the number of pilot wires requirement, we'll be using current summation transformer. We'll be using what? Current summation transformer. So what do you do here? We will sum up the three signals: R phase, Y phase, B phase, and neutral. This is known as what? Current summation transformer. Current summation transformer. So on the other side also we will be using the same current summation transformer: R dash, Y dash, B dash, and N dash. Okay. So here there will be voltages induced E2 and E1. So here also the same subtractive mode of connection is used. So if you use the current summation transformer, how many pilot wires are required? Only two pilot wires, because here we are summing up all the three phase signals. Here we are summing up all the three phase signals by using this current summation transformer. This type of protection is known as what? Translay relay. This is known as translay relay type of protection. This is known as translay relay type of protection. Understood my point? Okay. So by using current summation transformer, current summation transformer, number of pilot wires required, number of pilot wires required are required are. So I have said these pilot wires, if the length exceeds 10 kilometers, pilot wires are not preferred. Then they will use what? A carrier current communication. If the length exceeds 10 kilometers, using of these pilot wires is not preferred. There what you use? We will use carrier current communication. Okay. Pilot wires are feasible up to 10 kilometers length. Pilot wires can be used up to 10 kilometers, but if length exceeds 10 kilometers, if length exceeds 10 kilometers, Carrier current communication. Carrier current communication. Carrier current communication is used. Okay. If length exceeds 10 kilometers, what do you use? We will use carrier current communication. In carrier current communication, what do you use? In carrier current communication, what do you do, sir? On the same power line, this is power line. What do you do? We will inject a high frequency communication signal. We will transmit a high frequency communication signal. The frequency of this is around 30 kilohertz to 200 kilohertz. 200 kilohertz. So we will transmit the data by using this high frequency communication signal between 2 points. Now here we will be using a circuit that is known as line trap or wave trap, we can say. Okay, line trap or wave trap. What is the purpose of this line trap or wave trap? Here we will be using line trap, or we can also say it as wave trap. LC circuit. This is wave trap. What is the function of wave trap or line trap? Its function is to stop the communication signal beyond this point. So if you allow the communication signal high frequency, if you allow the high frequency communication signal onto the load side, load equipment get load equipment may get damaged. So what does the wave trap does? It it acts as a filter. It acts as a filter. It will offer high impedance for what? Communication signal and low impedance for power signal. Okay, it offers high impedance, high impedance, high impedance for communication signal, communication signal, and low impedance for low impedance for power signal, low impedance for power signal. It will not allow the communication signal to go beyond this wave trap or line trap, wave trap, or you can also call it as a line trap also. So it will not allow the communication signal to go beyond this, because if you allow this communication signal to go beyond that, the load equipment may get damaged, because that is a high frequency signal. Okay, it may affect the performance of the load, and there will not be any interference problem. Even if you inject power transmission on the same line and high frequency communication signal on the same line, there will not be any interference problem, because here the bandwidth is maintained very large. As the bandwidth is maintained very large, there will not be any interference problem. Understood my point? There will not be any interference problem because the bandwidth is maintained very large. So this is about relays. This is all about relays. So we have discussed about relays in detail. Okay. What is the function of relay? What is the function of relay? Relay function is only to sense. Relay function is only to sense. Then sensing itself will not give the total protection. Sensing itself will not give the complete protection. We should isolate the faulty section and healthy section. We should isolate the faulty section and healthy section. That is done by what? Circuit breaker. So if you observe here, you are using CT and relay, you are using here. The function of this relay is to sense. The function of the relay is to sense. Sensing itself will not give a complete protection. No. Then we need to provide what? Isolation. Isolation is to be done by what? Circuit breaker. And isolation is to be done by circuit breaker. This CB is nothing but circuit breaker. This relay has to coordinate with this circuit breaker. We have already seen the animation, how the relay and circuit breaker are coordinated. The function of the relay is to sense, and whenever the fault takes place, the relay will sense and it will initiate the trip signal to the circuit breaker. Then circuit breaker contacts will be separated and the faulty section and healthy section is isolated. Now the next topic is circuit breaker. Next topic is circuit breaker. Now let us start our discussion regarding the circuit breaker. Circuit breaker. So if you visualize a circuit breaker practically, if you see the practical view of circuit breaker, how it appears. If you see circuit breaker practically, how it appears. Have you seen the circuit breaker practically, how it will observe? So there will be a circuit breaker tank. There will be a circuit breaker tank like this. Yes or no? If you observe physically circuit breaker at the substation, there will be a circuit breaker tank. And in this tank, what you have? We will have two contacts. There will be two contacts, and these two contacts can be either kept closed or separated in the medium of insulation. One is fixed contact and the other one is moving contact. One is fixed contact and another one is moving contact. So the fixed contact and moving contact can be either kept closed or separated in the medium of insulation. This green one is what? Insulation. So how can you define circuit breaker? It is nothing but an electrical device which consists of two contacts which can be either kept closed or separated in the medium of insulation. So it consists of two contacts which can be kept closed or separated, which can be either kept closed or separated in medium of insulation. Okay. These two contacts can be either kept closed or separated in the medium of insulation. Now the question is, what is the purpose of this insulation? Why the insulation is required in case of circuit breaker? Why the insulation is required in case of circuit breaker? Now let us see what is the purpose of insulation. What is purpose of insulation in circuit breaker? What is the purpose of insulation in circuit breaker? So why the insulation is required, sir? Here, why the insulation is required? In the class, in the first class, I have said whenever the contacts get separated, there is a formation of arc. Whenever the fixed contact and moving contact get separated, there is a formation of arc. To quench the arc, we require what? Insulation. Okay. These two contacts are separated. There will be a formation of arc. If the arc is continuing, then the isolation is not completed. The arc is to be quenched. That quenching of arc requires what? Insulation. For quenching of arc, we require insulation. So what is the first property? Why the insulation is required here? First reason is when contacts are separated, when contacts are separated, there will be formation of arc. In order to quench the arc, in order to quench arc, we need insulation. Okay. In order to quench the arc, we need what? Insulation. So whenever the contacts are separated, there will be formation of arc. In order to quench the arc, we require what? Insulation. Okay. The second reason is, so here the operating voltages in the system, are very high. Suppose if you observe 220 kV, 400 kV, like that, 765 kV, operating voltages are very high. Okay. Operating voltages are very high. So just wait, sir. Okay. So operating voltages are very high. In order to provide proper isolation between the contacts, and ground, we require what? Insulation. The second reason why we require insulation is in order to provide proper isolation proper isolation between the contacts and and ground, we require insulation. Insulation. We need insulation for this purpose. Okay. So circuit breaker is nothing but it consists of two contacts which can be either separated or closed in the medium of insulation. So insulation is required to in order to quench the arc and to provide the isolation between the contacts or between the contacts and ground. Now, next, what are the properties of insulation that is required in case of circuit breaker? Properties of insulation that is required to be used in case of circuit breaker. So the insulation if you are using in circuit breaker, that should have what properties? The dielectric strength of the insulation should be high or low. The first property is dielectric strength. It should have high dielectric strength or low dielectric strength. It should have high dielectric strength or low dielectric strength. The dielectric strength of the insulation material should be very high. What happens if the dielectric strength is low? The spacing required for contact separation will be more. Then the size of the circuit breaker will become large. The size of the circuit breaker becomes large because if the dielectric strength is low, you need to separate the contacts by larger distance. So the size of the circuit breaker becomes large. That's why we should prefer the insulation. It should have high dielectric strength. It should have high dielectric strength. Dielectric strength. The dielectric strength should be very high. So if the dielectric strength is high, the spacing between the contacts is low. The spacing between the contacts is low. The spacing between the contacts is low. So first one is it should have high dielectric strength. Second one is, what is the second one? It should not result in fire. It should not result in fire. It should not result in fire because whenever the contacts are separated there will be formation of arc. That arc should not result in that due to that arc the insulation should not catch fire. It should not result in fire, and it should not have impurities. It should be free from impurities. Okay. And it should be free from impurities, and it should have heat dissipation capability. It should have what? Heat dissipation capability. It should have heat dissipation capability. Dissipation capability. So what do you mean by heat dissipation capability? Why the heat dissipation capability should have? Whenever the contacts are separated, there will be formation of arc. That arc will heat generate. That arc will result in heat generation in the insulation medium. So that heat must be properly dissipated. That heat must be properly dissipated. Apart from all this, one important property that the insulation should have is it should have arc quenching property. It should have what? Arc quenching property. Okay. It should have arc quenching property. Arc quenching property. So these are some of the properties that the insulation should have. It should have high dielectric strength. It should not result in fire. It should be free from impurities. It should have heat dissipation capability, and it should have arc quenching property. Okay, these are some of the properties that the insulation should have if you want to use in case of circuit breaker. Okay. Now I am going to what are the different types of insulations? What are the different types of insulations that are used? Okay, insulations insulations used in circuit breaker. Insulations used in circuit breaker. Insulation used in circuit breaker. What are the different types of insulations that are used in case of circuit breaker? We have air insulation circuit breaker, air brake circuit breakers. We have air blast circuit breakers. We have their air is the insulation, and we have oil circuit breakers. Oil circuit breakers where oil is the insulation medium. Where oil is the insulation medium. In case of oil, transformer oil or synthetic oil will be used in case of oil circuit breakers. And we have vacuum circuit breaker. Vacuum circuit breaker, where vacuum is the insulation. In case of vacuum circuit breaker, what is the insulation, sir? Vacuum is the insulation. Vacuum is the insulation in case of vacuum circuit breaker. And we have SF6 circuit breaker, where SF6 gas is the insulation. SF6 circuit breakers, we have SF6 gas as insulation medium. So these are the commonly used insulations in case of what? Circuit breaker. These are the commonly used insulations in case of circuit breaker: air, oil, vacuum, and SF6 gas. Air insulation, oil insulation, vacuum insulation, and SF6 gas as an insulation. So if you observe this SF6 gas, this SF6 gas, this SF6 gas is an electronegative gas. What are the properties of this SF6 gas? It is electronegative gas. Electronegative gas. Electronegative gas means it absorbs the electrons or releases the electrons. It absorbs the electrons at a faster rate. So as it is an electronegative gas, it absorbs electrons at a faster rate. It absorbs the electrons at a faster rate. As it is absorbing the electrons at a faster rate, arc can be quenched quickly. Arc can be quenched quickly. Arc can be quenched quickly. Except gas, it is an electronegative gas, so it can absorb the electrons at a faster rate. So the arc can be quenched quickly. Okay. Now, apart from that, it has high dielectric strength. It has high dielectric strength. Dielectric strength. Dielectric strength of SF6 gas is 2 to 3 times that of air. Okay. Dielectric strength of SF6 gas is 2 to 3 times. 2 to 3 times of air. 2 to 3 times that of air. So it has high dielectric strength, and the viscosity is low. Low viscosity. So if the viscosity is low, what happens? If the viscosity is high, the force required for contact separation will be more. If the viscosity is low, the contacts can be easily separated. Suppose if you move your hand in water and if you move the hand in oil, where the force required to move your hand will be more? Oil, because there the viscosity is high. In oil, viscosity will be high. So in case of SF6 gas, low viscosity is low. Okay. And this SF6 circuit breaker, it can be designed to any operating voltage level. SF6 circuit breaker can be designed to operate at any voltage level. SF6 circuit breaker can be designed to operate. SF6 circuit breaker can be designed to operate at any voltage level. Okay? Because that is the design criteria of that. So we can design SF6 circuit breaker to any voltage level. To any voltage level. Example, from 11 kV, 33 kV, 66 kV, 132 kV, 220 kV, 400 kV, 765 kV. Above also, we can design this SF6 circuit breaker. That's why it is known as modern power system circuit breaker. SF6 circuit breaker is known as what? Is known as modern power system circuit breaker. It is known as what? Modern power system circuit breaker, because it can be designed to operate at any operating voltage level. SF6 circuit breaker is known as what? Modern power system circuit breaker, because it can be designed to operate at any operating voltage level. I think you have got the idea about this. Okay. Now, now let us go for, I am saying when the contacts are separated, the arc formation is taking place. Now let us see why the arc formation takes place. Now let us go to the analysis why the arc formation takes place when the contacts are separated. Why formation of arc takes place when contacts are separated. When contacts are separated. So when the contacts are separated, why the arc formation takes place? Now let us analyze. This is very important for understanding how the circuit breaker behaves. Now let us analyze here. So initially, first let us consider initially initially when there is no fault, the circuit breaker contacts are closed. The circuit breaker contacts are closed. The circuit breaker contacts are closed, and there will be load current through the contacts. There will be load current through the contacts. Load current through the contacts. Now let us analyze. So the circuit breaker consists of what? Fixed contact and moving contact. So this is a fixed contact and moving contact. Initially the circuit breaker contacts are closed, and what there will be there's a load current. There will be load current through the contacts. Now what is the spacing between the contacts? Delta D is 0. Spacing delta D is what? Spacing between the contacts is 0 because the contacts are kept closed. So the spacing between the contacts is 0. So what about the resistance between the contacts? Resistance between the contacts is 0. And what about voltage drop between the contacts? Voltage drop between the contacts will be also 0. What about the heat generated? Heat generated will be also 0 because resistance is 0. Heat generated will be 0. Now, when short circuit fault takes place, what happens? Suppose when short circuit fault takes place, what happens? Relay senses the fault. Relay senses the fault. When short circuit fault takes place, relay senses the fault, and it will initiate the action of circuit breaker. Understand my point? When short circuit fault takes place, relay senses the fault and it initiates the action of a circuit breaker. Now let us see what happens when the circuit breaker contacts get separated. So when short circuit fault takes place, when short circuit fault takes place, what happens? When short circuit fault takes place, the relay senses the fault. Relay relay senses the fault and initiates action of circuit breaker. Action of circuit breaker initiates the action of circuit breaker. Okay. When short circuit fault takes place, relay senses the fault and it will initiate the action of a circuit breaker. Now the contacts start separating. When the contacts are just separated. Now let us analyze when when the contacts when the contacts are just separated by a small distance. When the contacts are just separated by a very small distance, what will be the case? Let us analyze. So when the fixed contact and moving contact are just separated by a very small distance. When the contacts are just separated by a very small distance, what happens? This is the spacing between the contacts. Delta D is very small. The spacing between the contacts is very less. Okay. Resistance between the contacts. Resistance between contacts R will be also less because spacing is less, resistance between the contacts is less. Voltage drop is also less. Heat generated is also less. But what about electric field intensity? E delta V by delta D. Here, the spacing between the contacts is very less. So the electric field intensity that is existing between the contacts is very high. Now let us analyze with an example. Here. So if you take the example like this, so delta V is some 100 volts, and the spacing between the contacts is 1 into 10 power minus 6 centimeters. Suppose if you take very just separated, whenever the contacts are just separated, what is the electric field intensity? Delta V by delta D. Now observe here 100 volts by 1 into 10 power minus 6 centimeters. So how much you get? 100 into 10 power 6 volt per centimeter. So when the contacts are just separated, the electric field intensity is very high. This is what electric field intensity is very high. So due to this high electric field intensity, it will result in what? Electric field ionization. Electric field ionization. Okay. So due to this high electric field intensity, due to this high electric field intensity, it will result in what? Electric field ionization. So whenever the electric field ionization takes place, large number of electrons will be released. Large number of electrons will be released, and the arc structures between the contacts. Arc is formed between the contacts. Between the contacts, due to what? High electric field intensity. Now, what is your analysis? When the contacts are just separated by a very small distance, their high electric field intensity will be existed. High electric field intensity will be existing between the contacts, which will result in what? Electric field ionization and results in formation of arc. So what is the reason? What is the reason for formation of arc? What is the reason for formation of arc here? What is the reason for formation of arc? High electric field intensity. Okay. So we can conclude that the reason for formation of arc, the reason for formation of arc is high electric field intensity existing between the contacts between the contacts when they are just separated, when they are just separated by a small distance. Okay. So what is the reason for arc formation? High electric field intensity. Will the contacts will be just separated by a very small distance? No. The spacing increases further. The spacing increases further. So when the contacts are further separated, when contacts are further separated, further separated. When the contacts are further separated, what happens? Now observe here. This is the fixed contact and this is the moving contact. So when the fixed contact and moving contact are further separated, what happens? The arc still continues to exist between the contacts because due to the high electric field intensity, large number of electrons are released. Due to that field ionization, large number of electrons are released. So the electrons which are released will collide with the other molecules. The electrons which are released will collide with the other molecules, and this insulation medium is heated up. Insulation medium is heated up. Medium is heated up. Insulation medium is heated up, and the arc still continues to exist between the contacts. When here the spacing is increased, no doubt. When contacts are further separated, when contacts are further further separated, the arc continues to exist. The arc continue, the arc continue to exist. The arc continue to exist, and electrons released collide with other molecules with other molecules and heat is generated and the insulation medium is heated. Electron collisions will release heat energy. Electrons collisions will release heat energy. So whenever the collision of electrons taking place, the heat is generated. So now, when the contacts are finally separated by the maximum distance, whatever the maximum distance that is there, whenever the contacts are finally separated by the maximum distance, now let us analyze. So when contacts are finally finally separated by maximum distance, when the contacts are finally separated by maximum, just wait, sir. When the contacts are finally separated by maximum distance. So what happens when the contacts are finally separated by maximum distance? Now this is a fixed contact and this is the moving contact. Whenever the contacts are finally separated by the maximum distance, the spacing between the contacts is more. Okay, The spacing between the contacts will be more, resistance will be more, current will be resistance will be more, voltage drop will be less, voltage drop will be less, and heat generation will be also less. Sorry, not heat generation. So electric field intensity delta V by delta D. As delta D is more, the electric field intensity is low, which is not sufficient to maintain the arc, not which is not sufficient to maintain the arc. But still, the arc continues to exist between the contacts due to temperature effect or thermal ionization. Due to temperature effect or thermal ionization. So, what is your observation? When the contacts are finally separated, when the contacts are finally separated by the maximum distance, the spacing between the contacts is more or less. The spacing between the contacts is more. Resistance between the contacts is also more. Resistance between the contacts is also more. Voltage drop is less. Voltage drop is less. The electric field intensity is not sufficient to maintain the arc. The electric field intensity is not sufficient to maintain the arc, but still the arc continues to exist due to temperature effect or thermal ionization. So what we can say, when contacts are when contacts are finally finally separated by maximum distance maximum distance when the contacts are finally separated by maximum distance, the spacing between the contacts is more, electric field intensity is less, which is not sufficient, which is not sufficient to maintain arc, to maintain, which is not sufficient to maintain the arc. But still, arc continue to exist, continue to exist due to temperature effect, due to temperature effect or thermal ionization. Okay. So what is your observation? When the contacts are finally separated by the maximum distance, when the contacts are finally separated by the maximum distance, the spacing between the contacts is more or less. The spacing between the contacts is more. The electric field intensity will be less. The electric field intensity will be less, which is not sufficient to maintain the arc. But still, the arc continues to exist due to what? Temperature effect or thermal ionization. Due to temperature effect or thermal ionization. Okay. So why the arc is forming? Arc initiation, arc initiation is due to what? Arc initiation is due to high electric field intensity, high electric field intensity, intensity or field ionization. We can also say field ionization, field ionization. The arc is initiating, and existence, arc existence when they are finally separated, finally separation of contacts, when arc existence when the contacts are finally separated, that is due to what? Temperature effect or thermal ionization, temperature effect or thermal ionization. Okay. So we have analyzed why the arc formation takes place, and why the arc is existing finally when the contacts are being separated. Now observe, when the arc formation takes place, why the arc formation takes place between the contacts. Initially, there is no fault in the network, there will be load current. But when short circuit fault takes place, what happens? When short circuit fault takes place, the relay senses the fault and initiates the action of circuit breaker. When short circuit fault takes place, relay senses the fault and initiates the action of what? Circuit breaker. So when the contacts are just separated by the very small distance, the electric field intensity is very high. The electric field intensity that is existing is very high. Due to that high electric field intensity, the electric field ionization takes place. Electric field ionization takes place, and the arc strucks between the contacts. And arc strucks between the contact. So what is the reason for arc formation or arc initiation? Due to high electric field intensity that is existing between the contacts when the contacts are just separated by a very small distance. Okay. Now when the contacts are further separated, arc continues to exist, and the electrons which are released will collide with the other molecules, and the insulation medium is heated up. When the contacts are finally separated, the electric field intensity that is existing is very low. This is very low, which is not sufficient to maintain the arc, but still the arc continues to exist due to what? Temperature effect or thermal ionization. Okay, so this is how the arc formation and arc initiation and arc existence going to takes place in case of circuit breaker. Okay, now I will take the doubt session. Now I will take the doubt session. If students are having doubt, you can raise the hand. So I will allow you to talk. If you have doubt, you can raise the hand. So I will allow you to talk. If you have any doubts, you can raise the hand so that I will allow you. Okay. Ankur,
Hello, sir.
ask your doubt.
So, what is the material used for moving contact and fixed contact?
That depends on the type of the circuit breaker. Okay. If you are in case of oil circuit breaker, air circuit breakers, and SF6 circuit breakers, we'll use copper contacts. But in case of vacuum circuit breakers, we'll be using copper tungsten alloy there. I'll tell about that later.
Okay, thank you, sir.
While construction, we will analyze that. Okay.
Okay, thank you, sir.
Okay. Mayan,
Hello, sir.
ask your doubt.
Hello, sir. Sir, what is busbar, sir?
Bus bar is nothing but it is a point or it is a conductor to which more than one equipment can be connected in parallel at the same time.
Okay, sir. And
That is
sir,
nothing
I sent one problem on WhatsApp, sir.
huh?
Hello.
Ask your doubt.
Sir, I am sent on one problem on WhatsApp group, sir. WhatsApp, sir.
Okay.
Sir, please solve
You resend
this problem,
you
sir.
resend that about the after this class. You just resend that. I will see and answer you.
Okay, sir.
Okay.
Thank you, sir.
Prudvi Raj,
Hello, sir.
ask your doubt.
Sir, in rotor winding protection,
Okay. What is your doubt in rotor winding protection? Prudviraj,
hello.
ask your doubt, sir.
Sir, in rotor winding protection, if a flux is changed intentionally, then this AB potentials will
Whenever you
be.
are changing intentionally, what happens is automatically the source voltage will also change. No,
Okay, sir. This is from source voltage. Okay. Okay, sir.
okay.
And one more thing is, sir, this one voltage balance differential relay.
Oh, okay. What is
Next
that?
slide.
Okay.
Sir, here only. Sir, why we need to keep two relays here? One
Because
relay
if
is sufficient.
suppose if you are using in case of distribution line between two different substations, their length is more, no?
Okay, sir.
Two different substations.
Okay, sir.
Their each substation has its own delay.
Okay, sir. Sir, coming to circuit breakers, sir, what is the difference between dielectric medium and insulation medium?
Insulation medium will have dielectric strength.
Means
Insulation is a medium, dielectric strength is a parameter.
parameter means dielectric materials and
Dielectric strength is a proper dielectric strength. That is how much voltage it can withstand.
yes, sir. What my
Insulation medium will have dielectric strength to withstand that. That means it will not allow the conduction through these two contacts. It will insulate, no?
Sir, my core doubt is for dielectric medium, if it got breakdown, it can restore its insulating values.
That depends on the case where you are using.
Okay, sir. And that's it, sir.
Okay, right. Just 3.
సార్
Ask your doubt.
సార్ ఒక రిలేకి ఇంకొక రిలేకి డిస్టెన్స్ ఎంత ఉంటుంది సార్?
Where?
నేను పవర్ ట్రాన్స్మిషన్ కానీ ఎక్కడైనా కానీ రిలేస్ కనెక్ట్ చేసినప్పుడు ఫస్ట్ రిలేకి సెకండ్ రిలేకి ఎంత డిస్టెన్స్ ఉంటుంది సార్?
ఫస్ట్ రిలే సెకండ్ రిలే అని ఏముండదు. ఎక్కడైనా సబ్ స్టేషన్స్ లలో రిలేస్ ఉంటాయి. రిలేస్ లైన్ లో ఏం కనెక్ట్ చేయమ్మా, సబ్ స్టేషన్ లోపల రిలేస్ ఉంటాయి.
అంటే డిస్టెన్స్ ప్రకారంగా ఏం కనెక్ట్ చేయరా సార్?
డిస్టెన్స్ ప్రకారం ఏమి ఉండదమ్మా, సబ్ స్టేషన్ లోనే ఉంటాయి రిలేస్. రిలేస్ మధ్యలో ఎక్కడ ఉండవు, సబ్ స్టేషన్ లోనే ఉంటాయి.
ఓకే సార్. సార్ 2 కాంటాక్ట్స్ దగ్గరికి అయినప్పుడే కదా సార్ ఆర్క్ అనేది ఫామ్ అయ్యేది?
When the contacts are just separated, initially when the contacts are closed, ఇక్కడ చూస్తే కాంటాక్ట్స్ క్లోజ్ ఉన్నప్పుడు ఆర్క్ ఏం ఉండదు. ఓకే, when they are just separated, high electric field intensity exists and arc structs between the contacts.
సార్ మీ వాయిస్ లో వస్తుంది సార్, మాకు కొంచెం
Initially when the contacts are closed, there will not be any arc. When the contacts closed position ఉన్నప్పుడు arc ఏం ఉండదు. Whenever they are just separating, then the high electric field intensity exists and arc will result between those two arcs. Okay.
ఓకే సార్.
Okay.
సార్ సార్ సపోజ్ ఇక్కడ ఫాల్ట్ ప్రాజెక్ట్స్ ఉంటాయి కదా సార్, అంటే చార్జర్ లో కానీ ఫాల్ట్ ఉన్నా కానీ లేకపోతే మనం మిక్సీ కానీ కనెక్ట్ చేసాం కదా సార్ ప్లగ్ లో, అప్పుడు మిక్సీలో కానీ ఫాల్ట్ అనేది అక్కడ అయినప్పుడు మనం పెట్టినప్పుడు స్విచ్ చేసినప్పుడు లైట్ బ్లింకింగ్ అవుతుంది కదా సార్.
I didn't get what you mean. Repeat your question.
సార్ మనము ఇప్పుడు చార్జర్ సపోజ్ చార్జర్ లో ఫాల్ట్ అనేది అక్కర్ అయినప్పుడు మనము చార్జర్ కానీ ఇట్లా మిక్సీ కానీ ఫాల్ట్ ఉందని చెప్తారు కదా సార్, అప్పుడు అది స్విచ్ కనెక్ట్ చేసినప్పుడు లైట్ వేసినప్పుడు బ్లింకింగ్ అనేది ఏర్పడుతుంది కదా సార్, అది ఎలా ఎందుకు ఏర్పడుతుంది సార్?
ఎక్కడ బ్లింకింగ్ అంటే
లైట్ ఇప్పుడు మనం ప్లగ్ లో కనెక్ట్ చేస్తాం కదా సార్ చార్జర్.
ఓకే,
చార్జర్ కనెక్ట్ చేసినప్పుడు చార్జర్ లో ఫాల్ట్ గానీ అక్కర్ అయినప్పుడు మనకు లైట్ వేసినప్పుడు లైటింగ్ అనేది బ్లింక్ అయిపోవడం కానీ ఇట్లా ఆగిపోవడం కానీ ఇట్లా అవుతుంటది కదా సార్. అలా ఎందుకు అవుతుంది సార్? అంటే
the relay in that equipment gets sensed that, and it will initiate the alarm. Here alarm is nothing but blinking of that circuit.
Sir,
అక్కడ ఏమవుతుందంటే అందులో లోపల ఉన్న రిలే సర్క్యూట్ ఆ ఫాల్ట్ ని సెన్స్ చేసి అక్కడ అలారం అనేది లైట్ బ్లింకింగ్ ద్వారా ఇండికేట్ చేస్తారు.
ఓకే సార్. సార్ దాన్ని ఓవర్కమ్ చేయడానికి ఏం చేస్తాం సార్?
We should clear that fault. That fault has to be removed, no?
Okay, sir.
The short circuit is taking place, we should remove that short circuit fault for clearing them.
Okay, sir.
Okay.
Thank you, sir.
Bhavani.
Good evening, sir. Sir, what exactly transient condition means, sir?
Transient means what? Sudden occurrence of the condition, and that will not exist for the total duration. That will not exist for total duration.
Okay. Sir, once explain rotor winding protection, sir. Just.
Rotor winding.
Yes, sir.
So here during normal condition, what you will maintain? We will maintain the node A potential same as node B potential. That will tune the rectifier circuit. Okay.
Okay, sir.
So node A potential, node B potential, if it is same, what will be the current to the relay? 0. Okay. Relay will not operate. But whenever this field winding is experiencing any fault, the node A potential will not be same as node B potential. That potential gets disturbed and it will allow the current to the relay and relay will operate.
What is the down circuit, sir? Down.
This one is rectifier circuit, sir. Because this is DC, no?
Yes.
That's why I have used here rectifier circuit. Rectifier.
Okay.
Okay.
Okay, sir.
Full bridge
That's it.
rectifier you can say.
That's it, sir. Thank you, sir.
Let us take doubts at the end of this class. Now, let's take break. I will take the doubts, remaining doubts at the end of the class. Come back at So welcome back, Rick. So we have discussed why the arc formation taking place. Okay, we have came to a conclusion that why the arc formation is taking place, why the arc formation is taking place due to high electric field intensity or field ionization, and the arc existence after final separation of the contacts is due to temperature effect, or we can say it as thermal ionization. Okay, now let us go for studying the arc properties. So the arc which is existing between the contacts after final separation, so the arc which is existing between the contacts, even when they are finally separated, is to be quenched, or it should be maintained same. The arc which is existing between the contacts, even when they are finally separated, is to be quenched. So in order to quench the arc, you should study the properties of arc. Now let us go for arc properties. What are the arc properties? Now let us discuss in detail. Okay. So what are the arc properties? Now let us see. So the arc is formed in the medium of insulation. Okay. Arc is forming in medium of insulation. Arc is forming in the medium of insulation. So here arc is modeled as non-linear resistance. Arc is modeled as what? Non-linear resistance. Okay. Arc is modeled as non-linear resistance. Arc is modeled as non-linear resistance. So arc is modeled as what? Very important objective type question. Arc is modeled as what? Non-linear resistance. Arc is modeled as non-linear resistance. Now, what is the power factor of the arc? What is the arc power factor? Arc power factor is dash. So here the arc is modeled as non-linear resistance. Arc is modeled as non-linear resistance. So as the arc is modeled as non-linear resistance, voltage across the arc and current to the arc will be in phase. The arc current and arc voltage will be in phase because it is modeled as what? Non-linear resistance. So what is cos phi? That is cos 0. Cos 0 is what? Cos 0 is 1. So cos 0 is 1. So what is the arc power factor? Unity. What is the arc power factor? Unity power factor. Arc power factor is unity. Okay. Because arc is modeled as non-linear resistance. Now, let us go for what is the temperature coefficient of the arc? What is the temperature coefficient of the arc? Temperature coefficient of arc is dash. So what is the temperature coefficient of the arc? Whether it is having positive temperature coefficient or negative temperature coefficient or zero temperature coefficient. Positive temperature coefficient or negative temperature coefficient or zero temperature coefficient. What do you mean by positive temperature coefficient? As temperature increases, resistance increases. As temperature increases, resistance also increases. Then we can say it as positive temperature coefficient. What do you mean by negative temperature coefficient? As temperature increases, resistance decreases. It is as negative temperature coefficient. Okay. So here temperature coefficient is positive or negative or zero. Zero temperature coefficient means as temperature increases or decreases, resistance does not change. Resistance remains same. Resistance will not change. Now we observe arc is having negative temperature coefficient. What is the temperature coefficient of the arc? Negative. So arc temperature coefficient is negative. So what is your observation? As temperature is increasing, resistance decreases. So for arc, as temperature increases, resistance decreases. Temperature increases, resistance decreases. Now let us observe the case study like this. As current increases, temperature increases, resistance decreases. Resistance decreases. As the arc current increases, temperature increases, arc resistance decreases. What about the voltage across the arc? What about the voltage across the arc? Voltage across the arc, how do you calculate? Arc current multiplied with arc resistance. Arc current multiplied with arc resistance. So here, as arc current is increasing, arc resistance is decreasing. Arc current is increasing, arc resistance is decreasing. So what is our analysis here? Arc voltage will almost remain what? Constant. Arc voltage will almost remain. Sorry, this has gone somewhere. Let's wait. Arc voltage is almost remained constant. Here the arc voltage is almost remaining constant because the arc is having what temperature coefficient? The temperature coefficient of the arc is negative. As the temperature increases, resistance decreases. The arc temperature coefficient is negative. Okay. So voltage across the arc almost remains what? Constant. Voltage across the arc almost remains constant. Understood my point? Now let us go for what about the arc conductance? Next property is arc conductance. Conductance of arc depends on what? Arc conductance G directly proportional to what? Number of electrons released, number of electrons released, number of electrons released, directly proportional to area of cross section of arc, area of, just wait, just sorry for disturbance. So arc conductance is directly proportional to number of electrons released, directly proportional to area of cross section of arc. Cross section of arc is directly proportional to area of cross section of arc, and inversely proportional to length of arc. And inversely proportional to length of arc. There was one objective asked in previous IES examination. Arc conductance directly proportional to option A given as number of electrons released due to that ionization, and area of cross section of arc. Third option is inversely proportional to length of arc. Fourth option, all the above. All the above is the correct option here. Understood my point? Arc conductance is directly proportional to number of electrons released, directly proportional to area of cross section of arc, inversely proportional to length of arc. Okay. So we should design the circuit breaker such that the arc conductance should be low. Arc conductance should be low means the area of cross section should be less. The area of cross section should be less, and the arc length should be more. Okay. And what about the heat generated by the arc? The next property is what about the heat generated by the arc? Heat generated by arc. What about the heat generated by the arc? How do you calculate? Heat generation is what? I square R into T. I square R into T. So here heat generation is directly proportional to what? I square R. Heat generation is directly proportional to what? I square R. So if you observe current density is what? Current per unit area. Current density is current per unit area. So from this, area of cross section is directly proportional to current. Area of cross section is directly proportional to current. So what about the resistance? Rho L by A. So resistance is inversely proportional to area of cross section of R. Now substitute in heat generation. Heat generation is directly proportional to I square R, directly proportional to A square into 1 by A. So heat generated by the arc is directly proportional to area of cross section of arc. Heat generated by arc is directly proportional to what? Area of cross section of arc. Very important. Here A is what? Area of cross section of arc. This is area of cross section of arc. Area of cross section of arc. Heat generated by arc is directly proportional to area of cross section of arc. Okay, don't confuse. There was one objective asked in transfer examination. He said that heat generated by the arc directly proportional to area of cross section, square of the area of cross section, cube of the area of cross section, area of cross section power 3 by 2. So it is directly proportional to what? Area of cross section of the arc. So here the arc is finally existing due to what? Heat that has been generated, that is temperature effect or thermal ionization. We should design the circuit breaker such that heat dissipation should be more, or the heat generation should be less. heat generation should be less or the heat dissipation should be more. That should be our design criteria. Okay. So these are the properties of arc. So what are the arc properties? Arc is forming in the medium of insulation. Arc is modeled as what? Non-linear resistance. So arc power factor is unity, because whenever you are modeling with non-linear resistance, arc voltage and arc current will be in phase. So arc power factor is unity. Okay. So what is the temperature coefficient of the arc? Arc is having negative temperature coefficient, and voltage across the arc almost remains constant. Voltage across the arc almost remains constant. Okay. What about the arc conductance? Directly proportional to number of electrons released, directly proportional to area of cross section of arc, inversely proportional to what? Length of arc. And heat generated by the arc directly proportional to what? Area of cross section of arc. Now, once you know the properties of arc, now let us analyze. So the arc which is existing between the contacts, the arc which is existing between the contacts is to be quenched or it is allowed to be continued. So the arc which is existing between the contacts is to be quenched, or you should allow the arc to continue. The arc is to be quenched, because if the arc is allowed to continue, there is a path for fault current. No, there is a path for fault current. So the arc is to be quenched. So the arc is to be quenched. So how to quench the arc? How to quench the arc? What are the theories that are helpful for quenching of arc? What are the theories that are helpful for quenching of arc? There are two theories. There are two theories which explain arc quenching mechanism. There are two theories which explain what? Arc quenching mechanism. Okay. Now, what are those theories? How they explain the arc quenching mechanism? Now let us see. So the arc which is existing between the contacts, even when they are finally separated, they are finally separated. The arc which is existing between the contacts, even when they are finally separated, is to be quenched. Is to be quenched. Is to be quenched. So how do you analyze this? There are two theories. There are two theories which explain arc quenching process. Arc quenching process. So what are those two theories which explain arc quenching process? I will state here. First one is energy balance theory. Energy balance theory. The second one is voltage race theory. Voltage race theory. Okay. So first one is energy balance theory. The second one is what? Voltage race theory. These are the two theories which explain what? Arc quenching process. These are the two theories which explain arc quenching process. Now, let us start the first one, that is energy balance theory. Energy balance theory. Energy balance theory. How this energy balance theory is stating that the arc is being quenched? What is the condition that must be satisfied for quenching of the arc? So here the arc is finally existing due to what? Temperature effect or thermal ionization. Arc is finally existing due to what? Temperature effect or thermal ionization. Okay. So here for quenching of the arc, what condition is to be satisfied? For quenching of the arc, what condition is to be satisfied? Here the rate of heat dissipation is greater than the rate of heat generation. If you can maintain the rate of heat dissipation greater than the rate of heat generation, the arc can be quenched according to which theory? Energy balance theory. So what is the condition that must be satisfied? According to energy balance theory, the arc can be quenched. The arc can be quenched. According to this energy balance theory, the arc can be quenched if we can maintain the rate of heat dissipation. The rate of heat dissipation. We can maintain the rate of heat dissipation greater than rate of heat generation. rate of heat generation. So what condition must be satisfied? We should maintain the rate of heat dissipation. Rate of heat dissipation greater than the rate of heat generation. Greater than rate of heat generation. So if you can maintain this condition, the arc can be quenched. According to which theory, sir? Energy balance theory. According to energy balance theory, we can if you can maintain this rate of heat dissipation greater than the rate of heat generation, the arc can be quenched. Okay. So now, if you observe the variation of heat generation with respect to resistance, the variation of heat generation with respect to resistance between the contacts, resistance between the contacts. So first let us analyze when the contacts are closed. When the contacts are closed, the resistance is what? Resistance is 0. When the contacts are closed, resistance is 0. And when the contacts are just separated, resistance increases. And when the contacts are further separated, further the resistance increases and the heat generation also increases. And when the contacts are finally separated, when the resistance becomes infinite, what happens? When the resistance becomes infinite, heat generation also becomes 0. Because when resistance is infinite, what is the current? 0. So heat generation is 0. So in between there is a possibility of what? Maximum heat generation. In between there is a possibility of maximum heat generation. Okay. So initially when the contacts are closed, resistance is 0, heat generation is 0. And when the contacts are finally separated by the maximum distance, suppose if the resistance is infinite, then also the heat generation will be 0. But in between there is a possibility of what? Maximum heat generation. So if you can maintain the rate of heat dissipation greater than the rate of heat generation during that period, the arc can be quenched. So how we can maintain? How we can maintain that condition? So we can get rate of heat dissipation greater than rate of heat generation by, so what are the conditions that you can maintain? By cooling the arc. If you can cool the arc, you can you can increase the rate of heat dissipation or not. By cooling the arc and by increasing the length of arc, increasing the length of arc. So if you observe this length and this length arc, two different lengths. Here the heat dissipation is like this. Heat dissipation is narrow. Heat dissipation is not problem. But if the length of the arc is increased, so what happens? Heat dissipation can be properly done. And by decreasing the area of cross section of arc, decreasing area of cross section of arc, because heat generation is directly proportional to what? Area of cross section of arc. If area of cross section of arc is less, heat generation will be reduced. Okay, heat generation will be reduced. By cooling the arc, by increasing the length of the arc, by decreasing the area of cross section of the arc, by splitting the arc. Suppose if you take a larger container and pouring hot water into that, where the heat dissipation can be easily maintained, or by splitting that water into 20 small vessels, heat can be easily dissipated. Small vessels easily dissipated. When you split the arc, you can easily maintain the rate of heat dissipation greater than the rate of heat generation. And constraining the arc. So you can maintain the rate of heat dissipation greater than the rate of heat generation based on this condition. So what is the first theory which explains energy balance theory? What is the first theory which explains the arc quenching mechanism? According to this energy balance theory, if you can maintain the rate of heat dissipation greater than the rate of heat generation, if you can maintain the rate of heat dissipation greater than the rate of heat generation, the arc can be quenched. So if we observe the variation of heat generation with respect to resistance between the contacts, initially when the contacts are closed, resistance is 0, heat generation will be 0. As the spacing is increased, the heat generation increases. And when the contacts are finally separated, if the resistance is infinite, again the heat generation will be 0. Okay? In between, there is a possibility of maximum heat generation. So if you can dissipate that heat, the arc will be quenched. So that can be done by cooling the arc, increasing the length of arc, decreasing the area of cross section of arc, splitting the arc, and constraining the arc. Okay. So that is about energy balance theory. Now let us go for the second theory, that is voltage race theory. Voltage race theory. Voltage race theory. So according to this voltage race theory, when we can say that the arc is quenched, what is the condition that must be satisfied? What is the condition that must be satisfied for quenching of the arc? What is the condition that must be satisfied for quenching of the arc? According to this voltage race theory, if you can maintain the absorption rate of electrons greater than the releasing rate of electrons, the arc can be quenched. If we can maintain, if we can maintain, if we can maintain the absorption rate of electrons, if you can maintain the absorption rate of electrons more than greater than releasing rate of electrons, if you can maintain the absorption rate of electrons greater than the releasing rate of electrons, arc can be quenched. So this is according to which theory? Voltage race theory. According to this voltage race theory, if you can maintain the absorption rate of electrons greater than the releasing rate of electrons, the arc can be quenched. So how can we get this? That we will observe. Or what are the other conditions that this voltage race theory says? Now let us observe here. So if you observe the AC current waveform, variation with respect to time. So initially the current magnitude is 0. At this point A, the current magnitude is 0. Initially the current magnitude is 0. It increases from 0 to maximum. And then decreases from maximum to 0. And again it decreases from maximum to 0. Again in this way it increases from 0 to maximum, again decreases from maximum to 0, and continues like this. So this is the AC current waveform. So now whenever the current magnitude is increasing from 0 to maximum, during this interval, if you observe the variation of voltage with respect to time between the contacts, the rate at which restriking voltage is increasing, between the contacts will be more than the rate at which dielectric strength is increasing. Between the contacts. Okay. So whenever the current magnitude is increasing from 0 to maximum, the rate of rise of restriking voltage will be more than the rate of rise of dielectric strength. Whenever the current magnitude is increasing from 0 to maximum, the rate of rise of restriking voltage will be more than the rate of rise of dielectric strength between the contacts. So during this interval, so what is our observation? During this interval, if we quench the arc, the arc will restrike. During this interval, if we quench the arc will restrike. Why the arc will restrike? Because restriking voltage is greater than the dielectric strength. So the arc will restrike. And if you observe the second case, when the current magnitude is decreasing from maximum to 0, and during this interval, if you observe the variation of voltage with respect to time between the contacts, voltage variation with respect to time during this interval, the rate of rise of dielectric strength between the contacts, dielectric strength at which it is increasing will be more when compared to the rate at which restriking voltage is increasing. So the rate at which restriking voltage increasing is less when compared to dielectric strength. So if you quench the arc during this interval, the arc will be quenched or it will be restriked. The arc will be quench. So A to B is preferred or B to C is preferred? B to C is preferred because the dielectric strength of insulation is more than the restriking. Just wait. Check my voice. Is my voice clear now? Is my voice is heard or not? Is my voice clear? Is it clear? Just raise the hand. If audio and video is clear, just raise the hand. If audio and video is clear, if audio and video is clear, just raise the hand, sir. If audio video is clear, just wait. If my audio and video is clear, just raise the hand. I think there is a problem in audio. Okay, just wait. Let us check this. So if you have any doubt, you can call me. Now is my audio clear? Now is my audio clear? Just raise the hand if audio is clear. Just raise the hand, all the participants. If audio is clear, just raise the hand. I request the participants to raise the hand if audio is clear. Okay, audio is clear now? Okay, right, thank you. Audio and video is clear. Now let us continue. Okay. If you have any disturbance, you can just call me on my number and I will be answering them. No issue. Right, thank you. Okay, sir. So, is it preferred to quench the arc during the first interval A to B or B to C? It is preferred to quench during B to C because dielectric strength of insulation will be more when compared to what? Restriking voltage. When compared to restriking voltage. So, during this period, if you quench the arc will not restrike. During this period, if you quench the arc will not restrike. I think you have understood that. Yep. So what we can make a note here. In case of AC current waveform, in case of AC current waveform, the current magnitude increases from increase from 0 to maximum and decrease from maximum to zero. So when the current magnitude is increasing from 0 to maximum, which voltage is more? Rays of restriking voltage will be more than dielectric strength. So when current magnitude increases from 0 to maximum, rate of rise of restriking voltage is more than rate of rise of dielectric strength, dielectric strength of insulation. So when the current magnitude is increased from 0 to maximum, the rate of rise of restriking voltage will be more than the rate of rise of dielectric strength of insulation. So even if you quench the arc during this interval A to B, if you quench the arc will restrike. So if we quench the arc, quench means remove. Quench arc restrikes. Arc will restrike. Okay. Now, if you consider the second case, when the current magnitude is decreasing from maximum to 0, rate at which dielectric strength is raising will be more than the restriking voltage. So if you quench the arc during that interval, the arc will not restrike. Okay. When the current magnitude decreases from maximum to 0, the rate of rise of dielectric strength of insulation the rate of rise of direct strength of insulation is more than rate of rise of rate of rise of restriking voltage. Okay, so if we quench the arc during this interval, the arc will not restrike. So if we quench the arc, if we quench arc during this period, arc will not restrike. Restrike. Arc will not restrike. So if you quench the arc during this period, the arc will not restrike. Okay, understood my point. So when the current magnitude is increasing from 0 to maximum, the rate at which restriking voltage is raising is more than direct strength. So if you quench the arc, it will restrike. And in the second case, when it is decreasing from maximum to 0, the rate of rise of direct strength will be more than the restriking voltage case. So the arc will quench during this period. Okay. So now the question is it preferred to quench? Now the question is it preferred to quench the arc? Is it preferred to quench the arc at current 0 point, at a zero crossover point, or non-zero point? Here zero crossover point is X and the non-zero point is what? Y. So is it preferred to quench the arc at current 0 point X or non-zero point Y? So which point is preferred to quench the arc, at current 0 point or non-zero point? That is the question. So which point is preferred? To quench the arc? Current 0 point is preferred. Why? What is the reason? Because if you want to quench the arc at current 0 point, the amount of insulation that is required will be less. So it is preferred to quench the arc at what? Current 0 point. So it is preferred to quench the arc. It is preferred to quench arc at current 0 point. So that the insulation required will be less. So this is about voltage raise theory. So what is the condition that must be satisfied according to the voltage raise theory? If you can maintain the absorption rate of electrons greater than the releasing rate of electrons, the arc will be quenched. Or the other condition can be written as this: the rate of rise of dielectric strength of insulation should be greater than the rate of rise of restriking voltage. Okay. So if the dielectric strength is raising more when compared to the restriking voltage, the arc can be quenched. That is possible when the current magnitude is decreasing from maximum to 0. Okay. These conditions must be satisfied. So these are the two theories. Which explain the arc quenching process. What? Arc quenching process. Now let us discuss what are the methods of arc quenching. So there are two methods. What are the methods of arc quenching? There are two methods here. One is high resistance method. Second one is low resistance or current 0 method. There are two methods of arc quenching. First one is high resistance method. Second one is low resistance or current 0 method. Okay. First one is high resistance method. Second one is low resistance or current 0 method. So how the arc will be quenched according to this high resistance method? Now let us see. Okay, now let us analyze about this high resistance method. This high resistance method, how the arc is quenched? Here, what is the equation for arc current? Arc current is nothing but voltage across the arc by arc resistance. Okay. So in a high resistance method, the arc current is being reduced to zero. Arc current is reduced to zero by increasing the resistance of the arc. If you increase the resistance of the arc current reduces to zero. Understood my point? If you increase the resistance of the arc current will be reduced to zero. Okay. So, what is our point? In high resistance method, in high resistance method, high resistance method, arc current, arc current is reduced to reduced to zero by increasing the resistance of the arc, by increasing the resistance of arc. So in case of high resistance method, arc current is reduced to zero by increasing the arc resistance. Okay. So this high resistance method can be, it can interrupt the arc, it can quench the arc in both AC current as well as DC current. It can quench the arc for both AC and DC, but it is preferred for only DC braking. It can be, it can break both AC currents as well as DC currents, but it is preferred for breaking, it is preferred for breaking DC currents only, because now let us see this high resistance method, high resistance method, high resistance method can break both AC and DC currents, DC currents, but it is preferred for breaking, it is preferred for breaking DC currents only, DC currents only. Why it is preferred for breaking DC currents only? What is the reason? Because because in case of DC, in case of DC, no natural current zero point exists. No natural current zero point exists. Current zero point exists. Whereas, whereas in AC, natural current zero point exists. Natural current zero point exists. Zero point exists. Okay, current zero point. So in case of DC, will there be any natural current zero point? No. In case of DC, there will be no natural current zero point existing. In case of DC, there is no natural current zero point existing. But AC, natural current zero point exists. So in case of DC current, so in case of DC current, if you observe variation with respect to time, there is no current zero point. Naturally, current zero will not exist. So here you need to forcefully reduce the arc current to zero by increasing the resistance of the arc. By increasing the resistance of the arc, we need to reduce the arc current to zero. So, but whenever you are observing the AC current waveform, natural current zero points are available. Naturally, you will get what? Zero crossover points. Naturally, you will get zero crossover points. So, how do you increase the arc resistance? How can we increase the arc resistance? What is the formula for arc resistance? Rho L by A. Rho L by A. So, arc resistance, how do you increase? By increasing the length of arc, length of arc. So by increasing the length of arc. So if you are using flat contact, suppose if you are using these are the flat contacts. Okay, if you are using flat contact arrangement, so this is the spacing between the contacts, but if you are increasing the spacing, what happens? D2 is greater than D1. D2 is greater than D1. So size of the circuit breaker should increase or not? Size of the circuit breaker also increases. So instead of using flat contact arrangement, we can go for special contact, special contact arrangement, special contact arrangement. How that arrangement will be like this. So this is a special contact arrangement. So this is the fixed contact and the moving contact. This is the fixed contact and moving contact. So whenever the contacts are separated, The electric field intensity it will be high at the contact edges. So here you will get more arc. The arc will be struck like this. Okay. So the electric here the length of the arc will be more. So that's why we'll prefer what special contact arrangement rather than flat contact arrangement. So that we'll get more arc length. Arc length will be more. Okay. So one is we can increase the arc resistance by increasing the length of the arc. Second one is arc resistance is to be increased. For that, for increasing the arc resistance, we need to decrease the area of cross section of arc. Decrease the area of cross section of arc. Decreasing the area of cross section of arc. How you can decrease the area of cross section of arc? Suppose when the fixed contact and moving contact are separated, there will be formation of arc. There will be formation of arc. So if you apply high pressure air, high pressure air is blasted across the arc, then what happens? The arc will stretch like this. The arc will stretch like this. So whenever the arc is stretched, its area of cross section decreases and arc length also increases. Length of the arc increases whenever the arc is stretched. Whenever the arc is stretched, what happens? Its area of cross section decreases and arc length increases. Arc length increases. Okay, arc resistance is increased. Next, cooling the arc. Cooling of arc. So if you apply high pressure cool air, cooled air, if you apply, then it will increase the heat dissipation capability. Cooling of arc and constraining of arc, splitting of arc, splitting of arc. By applying all this, we can increase the resistance of the arc. We can increase the resistance of arc. So if you observe air blast circuit breaker, if you observe air blast circuit breaker, so whenever the fixed contact and moving contact are separated, the arc is struck between the contacts. So the arc which has been formed between the contacts is to be quenched. So here we have arc runners. So what do you have here? Arc runners will be there. Arc runners will be there. And arc splitters will be there. Arc splitters. These are what? Arc splitters. Sorry. Arc splitters will be there. At the end of the arc splitters, what do you have here? Here you have insulation. Here solid insulation is placed. So here this one is insulation. So what happens here? Whenever in order to quench the arc in case of air blast circuit breaker, what you will do? We will apply high pressure cool air. High pressure cool air. High pressure cool air is blasted across the arc. Then arc will run along the arc runners. So whenever the arc is running along the arc runners, length of the arc increases, area of cross section of the arc reduces. Length of the arc increases and area of cross section of the arc reduces. And whenever it reaches the arc splitters, what happens? Arc is splitted like this, and this insulation will not allow the arc to continue. So the arc is being quenched. So this is how an air blast circuit breaker is operated. Here, length of the arc is increased, area of cross section is reduced, arc is being splitted, arc is being cooled, and arc is constrained. All the conditions are satisfied in this air blast circuit breaker. Okay, all the conditions are satisfied or not? Yes or no? So this is about high resistance method. Now let us observe this low resistance method. So let us go for low resistance or current zero method. So what about this low resistance or current zero method? It can be used for only AC current interruption. It can be used for only AC current breaking. Because natural current zero points are available only in case of AC. So if you observe the AC current waveform with variation with respect to time, natural current zero points are available. Naturally you will get what? Current zero points. So naturally you are getting what? Current 0 point. Okay. What is the supply frequency? Supply frequency is 50 hertz. 50 hertz means 50 cycles per second. 50 cycles per second. So in 1 second you'll get 50 cycles. In 1 second you'll get 50 cycles means in 1 second you'll get 100 natural current 0 points. 100 natural current 0 points are obtained. So at this current 0 point, if you can maintain the absorption rate of electrons greater than releasing rate of electrons, the arc is being quenched or not. So at this current 0 point, if you can maintain absorption rate of electrons greater than releasing rate of electrons, the arc is being quenched. But this is not suitable for breaking DC current, because in case of DC, natural current 0 points are not available. So this low resistance or current 0 is applicable only for what? AC current breaking. It is only applicable for AC current breaking. Okay, I think you got this. So these are the methods of arc quenching. Okay. Now I will stop here. I will take the doubt session now, and in the next class we will continue. So I am lowering all your hands. I will lower all your hands, and if you have doubt, you can raise your hand and ask. So if you have doubts, you can raise your hand and ask, sir. I will allow you.
Sir,
Ask your doubts.
sir, yesterday's PDF isn't uploaded yet now, sir.
Okay, I will ask them to upload.
Yes.
I have
That's it.
already sent it to them.
Oh.
Yeah, if you have my WhatsApp number now, you just send it to me. I will forward that this Autodesk file. Then you can view it.
Okay.
Sir,
Ask your doubts.
sir, syllabus పంపిస్తారా sir?
Syllabus, whatever I am teaching, the total will be there in the syllabus, and still I will also give the description at the end of that.
Okay, sir.
Jayashree.
Sir, good
Ask
evening,
your-
sir.
Good evening.
Sir, in page number 35,
What is your doubt?
sir, in that you have specified arc is modeled as non-linear resistance.
Yes.
Sir, what do you mean by that, sir? I cannot understand.
Because here, if you observe, when the contacts are separated, fixed contact and moving contact are separated, this arc is forming in the medium of what? Insulation, no? This arc is forming in the medium of what? Insulation.
Insulation. Yeah.
So insulation is modeled with resistance, no?
Okay.
That is non-linear in nature. That's why arc is modeled as
Non-linear
non-linear.
in the sense?
Huh?
Sense is not, sir, non-linear in the sense it is
If you-
differing.
If you observe the VI characteristic, it will not be linear.
Okay, in VI characteristics, sir.
In VI, if you observe the VI characteristic of that resistance, it will not be linear. That is the meaning of non-linear.
Okay, sir. Sir, also in high resistance method. Okay, sir. In high resistance method, sir.
Okay.
One more doubt, sir.
What is your doubt?
Sir, in that you have drawn a graph where IDC we made our arc to 0 point.
Yeah.
Sir, what is that meaning, sir?
So if you go on increase the arc resistance, what happens? If you go on increase the arc resistance, what happens? So as the arc resistance is increasing, arc current reduces. No.
Sir?
Here we are reducing the arc. We are reducing that arc current to 0.
Yes,
because
sir.
arc is to be quenched. No.
Yes, sir.
That is forcibly done by increasing the resistance of the arc here.
How is that made, sir?
Because arc current relation is what? Voltage across the arc by arc resistance. So if you increase the arc resistance, arc current reduces or not?
Yes, sir.
That can be done by increasing the length of arc, reducing the area of cross section, pulling the arc, splitting the arc, constraining the arc like this.
Okay, okay, sir. Sir, in the before or after page of that graph, sir, you have written DC preferred for DC currents only.
This is preferred for breaking. It is preferred for breaking DC currents only, because in AC current, if you observe, naturally you will get the zero current. Natural 0 points are available. Okay.
Okay,
Naturally,
sir.
you are getting this zero crossover. No need to get by forcing. Okay,
Okay.
so that we can use this low resistance or current zero method.
Sir, can you once again tell the difference why it is preferred for DC and not preferred
Here,
for
if you are going for this, if you are using this high resistance method, if you are using this high resistance method for breaking AC currents, the length of the circuit breaker, the size of the circuit breaker becomes large. Okay,
Okay, okay.
size of the circuit breaker becomes large. So moreover, in AC there are natural current zero points are available. No, you no need
Yes,
to
sir.
forcibly reduce to zero. Okay, naturally the
Okay.
current zero point is available, so that we can use this.
Okay, sir. In case of DC, we have to bring the arc resistance to
Yeah. By increasing the
0.
resistance of that.
So that's why we are having,
Yeah,
or we are preferring it for DC.
yeah.
Okay, sir. Thank you, sir.
Okay. Yateshwar. Yateshwar Penta.
Sir, page number 18F.
Page number 18. What is your doubt?
Sir, here when fault takes place, E1 and E2 are not same, right now, sir?
Yeah. Then
So then
there
relay.
will be current through the relay.
So then relay will operate, right, sir?
Yeah, it will operate.
Sir, but you have written here relay will not operate.
I have the normal conditions, the relay will not operate, sir. First I have shown this total explanation. First I have shown normal condition. Then I have taken the short circuit fault. Then I have said E1 and E2 will not be same. Then the relay will not.
Okay, sir. Okay.
So yes, then the secondary side coils are connected in subtractive mode. E1 and E2 are equal, and
Yes.
it will not operate. This is during what condition? Normal operation.
operation.
Okay. Normal
Sir.
operation. Okay.
Yes, sir. Here
When fault takes place, E1 and E2 are not same. Relay will operate.
here will not operate in your written. Okay.
Sorry, relay will operate. By relay will operate. Sorry. Okay.
Yes, thank you, sir.
Okay. Sharat.
Sir,
Ask your doubt.
sir, in voltage race theory,
Uh,
you said that absorption rate of electrons is greater than releasing rate of electrons.
yeah.
But here you told that about only dielectric strength and restriking voltage. How can
that,
you?
Here I have said about what? So if you observe here, during this interval, the current magnitude is increasing. So here, to maintain the absorption rate of electrons greater than releasing rate of electrons is difficult. But here, the rate at which the current magnitude is decreasing. Okay, you can here in this region you can easily maintain the absorption rate of electrons greater than releasing rate of electrons. That is from B to C.
In BC region, absorption rate is more than.
We can maintain that.
Okay, sir. Another doubt.
Huh?
Another doubt, sir.
Ask her.
So in high resistance method, you told that we are preferring only to break the DC current only, sir.
Yeah.
But actually, how can we do, sir? Actually, both will break, no, sir, AC and DC.
It will break both, sir. I am not saying it will not break. But here it is not preferred for breaking AC, because here if you want to increase the resistance of arc, the size of the circuit breaker becomes large. You should increase the length, no? Size of the circuit breaker will become larger. So using larger size circuit breaker is not preferred. Understood my point?
Yes.
Okay. So here the size of the circuit breaker becomes large or not?
Yes, sir.
That's why it is not preferred.
Okay, thank you, sir.
Okay. Sajjan Singh.
Good evening, sir.
Ask your doubts.
Sir, on page number 19, how we reduce the number of pilot wires, sir? Please help me.
By using current summation transformer. Page number 19.
Yes, sir.
Here you have used current summation transformer. No, here each phase requires two pilot wires if you are using individually. But if you sum up those three phase signals, automatically you require only two pilot wires here. Okay.
Sir, how we add all these phases?
So here you have the CT of R phase,
Yes, sir.
CT of Y phase, CT of B phase. Yes or no?
Yes, sir.
Now CTs of R phase, Y phase and B phase. Now here you should connect one R here and the other to neutral. And this is R and this is connected to neutral. This is to be connected between B and neutral like this.
Star connected, sir.
You can say that it has star connected.
Okay. Thank you.
Okay.
Okay.
Are you there?
Yes, sir. Yes, I got it, sir.
Okay. Rajit Tyagi.
Hello, sir.
Ask your doubt.
Sir, I have a general doubt, sir. What is the value of the power generated at the generating station, sir?
What do you mean by that? That depends
Like,
on the
sir, what is
capacity. That depends on the capacity of generator.
it is not fixed, no, sir.
It is not fixed.
Okay, and sir, what is the significance of this quantifying this the transmission wires that is 11 kV, 33 kV, 66 kV? What is the significance of this, sir? These quantities?
There is no actually the voltage regulation previously that was 10% voltage regulation was allowed. Okay.
Yes, sir. Yes, sir.
So if you want to get 100 volts means you should operate at 110 volts at the
Yes,
required
sir.
end point.
Yes,
That's
sir.
why they have gone for that. But now there is no standard of using that. Sometimes they are violating that also.
No, sir, I'm asking that why even suppose we are 11 kV we are using, we are transferring from one place to another. So we still need 10 kV. Why we are using this specific numbers, 10 kV or 30 kV or
That's what
60?
I'm saying. No, there is no standard use of that. Actually, they have followed one standard there.
Okay.
But actually, the drop that is the voltage regulation was around 10%.
Yes, sir.
So to allow that, they have gone for that. There is no other need. That is the standard allowed. That is the standard made. That's all.
Okay. Thank you.
Sometimes nowadays they are violating that one. Suppose if you take 765, there is no
Yes, sir.
other. There is
Okay.
multiplication.
Thank you, sir.
Dwarakesh S.
Sir.
Are you there?
Yes, sir.
Speak louder, sir.
Hello.
Ask your doubt.
Sir, can you explain Earth theory, sir? Earth balance theory.
Energy balance theory.
Hello.
Energy
Yeah.
balance.
Sorry. Energy balance theory. Sorry.
So here if you observe. So according to this energy balance theory, if you can maintain the rate of heat dissipation greater than the rate of heat generation, the arc will be quenched. So why this condition is coming means the finally when the contacts are separated, the arc is existing because of thermal ionization or temperature effect. Arc is finally existing due to what? Thermal ionization or temperature effect. So based on this energy theory was formed. And if you observe the variation of heat generation with respect to resistance between the contacts, initially the contacts are closed, the resistance will be zero, heat generation will be zero. So when the contacts are just separated, heat generation increases like this. And when the contacts are finally separated by the maximum distance and the resistance is infinite, if the resistance is infinite, current will be zero, heat generation will be zero. So this you can maintain by cooling the arc, increasing the length of arc, decreasing the area of cross section of arc, splitting the arc and constraining the arc.
Sir, can you explain voltage race also, sir?
So here, if you can maintain the rate of rise of dielectric strength between the contacts greater than the rate of rise of restaking voltage, the arc will be quenched. Or it can be also said as, if you can maintain the rate of absorption rate of electrons greater than the releasing rate of electrons, the arc will be quenched. Okay. So here, if you observe, when the current magnitude is increasing from 0 to maximum, the rate at which restaking voltage is increasing will be more than the dielectric strength. So this period is not preferred, because if the arc is quenched, again it will restrike. So it is preferred to quench the arc during B to C. In this period, dielectric strength raise is more than the restaking voltage, because here you can easily maintain the absorption rate of electrons greater than the releasing rate of electrons. So the arc will be quenched according to this theory.
Okay, sir.
Right. G. Vaishnavi,
Sir, in 42 years, sir.
what is your doubt?
Sir, in this, when current magnitude increases from 0 to maximum, then you said restriking voltage is greater than dielectric strength.
The rate at which it is raising is more. Okay.
Sir, how can you say that restriking voltage
That
is
is
greater?
observed between the voltage observed between the contacts with respect to time. Okay. Kumar.
Hello, sir.
Ask your doubt.
Sir, can you explain once about unbalanced loading?
Explain about
Unbalanced loading, sir.
unbalanced loading. So here, load. What is the difference between balanced load and unbalanced load? Balanced load means equal in magnitude and phase displaced by 120 degrees. Then they are said to be balanced load. Unbalanced loading means not equal in magnitude or not phase displaced by 120 degrees. Then we can say that loading is unbalanced. So whenever the loading is unbalanced, balanced, there will be only positive sequence currents. But whenever the loading is unbalanced, there will be positive sequence currents and negative sequence currents. So we can sense this unbalanced loading by using this negative sequence relay. By using the negative sequence relay, we can sense the unbalanced loading. So this can be constructed using this bridge type structure. During normal condition, the bridge is tuned to be under balanced state. So whenever the bridge is balanced, there will be no current through this relay during normal condition. But whenever the bridge becomes unbalanced, that will result in current to the relay, and the relay will operate. That is nothing but negative sequence relay. For that, the time of operation is inversely proportional to square of the current.
Sir, in earth relay, you said that, sir, for discrimination of LG-bot, we use earth relay.
Yeah.
Sir, in the operation of earth relay is based on neutral current.
Yeah.
Okay. Sir, even though there is no fault, if the load is unbalanced, neutral current is present,
But
sir.
that's what, no, we will allow the unbalance only up to 10 to 20%. That's why I have set the earth relay to 10 to 20%.
Okay.
So getting exactly balance is difficult, sir, because loads are continuously varying parameters, no?
Yes.
Getting exact balance is difficult. That's why even if it is variation around 10 to 20%, we treat the system as balanced, and we will go for balanced calculations.
Sir, one more doubt, sir. In construction of impedance relay, we use balanced beam magnetic.
Balanced
tape.
electromagnetic attraction.
Sir, actually, that is an alternative, that is oscillations developed for AC.
But here both sides you have the same, then there will not be any problem.
Then there will not be any problem, sir.
Here we have both sides the same force now. It will not create any problem.
Sir, if the voltage and current are in not phase,
But
then
if there is only one quantity, it will provide pulsating force.
yes, sir. When
During
the
normal condition, both are same, no?
mount, sir, but
Both
voltage.
are same, so it will not create any oscillations because they are equal and acting opposite on the same balance. Okay.
Okay, sir. Thank you, sir.
Rameshwari Kranti. Rameshwari Kranti.
Hello, good evening, sir.
Good evening.
Sir, where it is preferred to quench the arc, sir, at X point or Y point?
At
I
current
didn't.
0 point. At current 0 point.
Once explain that, sir.
At current 0 point, the amount of insulation required will be more or less. Less. That's why it is preferred to quench the arc at that period.
Once explain, sir, with the slide. I really didn't understand that.
So here if you observe, the amount of insulation required will be more if you are quenching the arc at non-zero point, because the current is existing here. Again, you should forcibly reduce to 0. So the insulation required will be more if you are quenching at non-zero point. At current 0 point, already the current is 0, so amount of insulation required will be less. So the arc can be easily quenched at that period. Okay?
Yes, sir. Sir, another doubt. Sir, when the contacts are just separated and separated by maximum distance, in both cases, delta V decreasing, sir. What is that, sir? Delta
At both
V
the cases,
delta V is decreasing, sir.
delta V is less,
Why,
not
sir?
decreasing. That is less I have indicated. So in the first case also, here the voltage drop is less because resistance is less. No, voltage drop will be less. Okay.
Okay.
And even when the contacts are finally separated, here resistance is more, but the current will be less. Okay. V is equal to I into R. No.
Yes, sir.
The voltage drop will be less because current is less here.
Sir, in rotor winding protection, how that is working, sir, basically? Rotor winding protection.
Protection. So during normal conditions, the node A potential and node B potential is tuned to be same. Okay. So same potential means it will not allow any current through a relay. But whenever the fault takes place on this field winding, this node A potential gets disturbed. That will allow the current to relay and it will operate. Okay.
Sir, what is the role played in that, sir? Rectifier. We put
Because
a
this
rectifier.
node is at A, that is negative. This is DC potential. No, this is DC generator here.
Oh, okay, okay, sir. DC generator.
Yeah, that's why you need DC here.
With the help of rectifier only, we are operating the relay, sir.
No, with the help of not rectifier. By rectifier, you are getting a one more DC point here.
Ah, okay, sir. I got it. Thank you, sir.
Okay. Gautami. Venkana.
Hello, sir.
Ask your doubt.
Sir, what is mean by tertiary, sir? I didn't
Tertiary
understand.
means third. Generally, any transformer will have primary and secondary, no?
Okay.
Third winding is known as tertiary winding. Okay.
Okay, okay. Sir, what is the need of tertiary winding in that, sir?
Because here you require excitation of voltage coil and current coil, no?
Okay, sir.
And that current should be circulated only during that harmonic point. So that delta circuit will allow the currents during harmonic induced voltages.
So tertiary nothing but harmonic ni
No. There
circulate
is a winding. Yeah? Actually, it will allow the circulating currents for the harmonic induced voltage. That's why we'll use that.
Okay, okay.
Okay.
Okay. Sir, can you open that slide, sir? I will screenshot it.
Whatever relay.
Yeah, sir. Before this, after that slide, sir.
This one.
Yeah, sir. And next one also, sir. Okay, thank you, sir.
student.
Sir,
Ask your doubt.
sir, can you say textbook which one is preferred?
Textbook you can use CL Vadva, Power System CL Vadva, and Nagarath and Kotari also. Power System by Nagarath and Kotari. So I will say at the end, sir, because once you have the total knowledge of this, then you can refer any book easily. That's why at the end I will give all the books which have to be referred. And Power System Production by Badri Ram also you can use.
Okay, sir.
Okay.
Thank you,
Sir,
sir.
Ask your doubt.
sir, the low resistance or current zero method, can you explain one, sir?
In low resistance or current zero method, here the in case of this is preferred only in case of what AC, okay?
Yes.
Because here natural current 0 points are available. At this point, you can easily maintain absorption rate of electrons greater than the releasing rate of electrons by imposing the insulation between the contacts. Okay. Okay, right. Pramod,
Hello, sir.
ask your doubt.
Sir, what is the significance of special contact over flat contact?
So, if you observe here flat contact for the same distance, the size of the circuit breaker becomes large. Okay, because the arc structures like this. Okay. But if you are using special contact, electric field intensity at the edges will be more, no? The arc will struck like this. So for the same length, the size of the circuit breaker will be reduced by using this special contact arrangement.
Okay, sir.
Okay, got it.
Thank you.
Hello, sir.
Hemavardhan ready.
Sir.
Hemavardhan ready.
హలో
Ask your doubt.
సార్ మనకు టైప్ ఆఫ్ ఆపరేషన్ బట్టి 5 టైప్స్ ఉన్నాయి కదండి సార్
Type of?
టైమ్ ఆఫ్ ఆపరేషన్ బట్టి రిలేస్ 5 టైప్స్ ఉన్నాయి కదా
Okay.
అంటే ఏ అపారటస్ దగ్గర ఏ రిలే వాడతారు అంటే ఆల్టర్నేటర్ దగ్గర ఇన్స్టాంటేనియస్ అలా ఏమన్నా ఉన్నాయా సార్
That depends on the application, sir. Yesterday we have discussed about distance protection, no?
Yes.
There unit 1 is instantaneous, unit 2 is with certain time delay, unit 3 is with further time delay. Okay. Generally the overcurrent relays which we are using in case of the protection is inverse type relays.
అంటే ఇప్పుడు ఆల్టర్నేటర్ దగ్గర ఇన్స్టాంటేనియస్ వాడాలి కరెంట్ ఎక్కువ వస్తుంది కాబట్టి ఫాల్ట్
అట్లా ఏం లేదు, అక్కడ యూజ్ బట్టి వాడతారు జనరల్ గా. అక్కడ వేరే ఎక్విప్మెంట్ ఏం డిస్టర్బ్ లేకపోతే ఇన్స్టాంటేనియస్ ఆపరేషన్ వాడతారు.
సరే థ్యాంక్స్ సార్.
ఓకే
సార్.
ఆస్క్ యువర్ డౌట్.
సార్ వాట్ అవర్ రిలే ఒకసారి. వాట్ అవర్ రిలే.
Here, if you observe, this watt-hour relay consists of what? Voltage coils and current coils. To excite that voltage coils and current coils, we'll use auxiliary transformer, primary, secondary, and tertiary. Okay, 3-winding transformer use. Primary is directly connected to the alternator winding output. Secondary side, voltage coils are connected. Tertiary side, we will connect the current coils. During normal condition, the supply voltage is balanced and it consists of only 50 Hz frequency component. But whenever the interturn fault takes place, what happens? The voltage waveform will be distorted like this. This distorted voltage consists of harmonics. So this delta circuit offers the closed path for harmonic contents, and the current coils will be activated and the relay will operate.
Sir, next page also open just screenshot. Next page, sir. Screenshot. Okay, sir. Thank you, sir. Thank you, sir.
Mamata.
Sir.
Ask your doubt.
Sir, in generating stations, active power we can generate, but what about reactive power, sir?
So by using alternator, that is synchronous generator, we can generate both active power and reactive power. If you are using induction generator, there you can generate only active power. That's why we will prefer synchronous generators.
Okay. Sir, next one, in two-wire system, a single phase load, two pilot watts uses somewhere, sir. Are the three-phase four-wire, how many pilot watts uses?
ఫోర్త్ వైర్ న్యూట్రల్ కి ఏం పైలట్ వైర్ అవసరం లేదు. యాక్చువల్గా ఈచ్ ఫేజ్ ఒక్కొక్క ఫేజ్కి 2 వైర్స్ అవసరం అవుతాయి. అయితే 3 ఫేజ్ సిస్టమ్ వచ్చేసరికి 6 వైర్స్ అవసరం పడుతున్నాయి. 6 వైర్స్ అంటే కాస్ట్ ఇంక్రీజ్ అవుతుంది. అందుకనే మనం కరెంట్ సమ్మేషన్ ట్రాన్స్ఫార్మర్ యూజ్ చేసి నంబర్ ఆఫ్ పైలట్ వైర్స్ని రెడ్యూస్ చేస్తాం.
Okay, sir.
Okay.
Sir, once explain cooling arc method in high resistance.
Using
Cooling arc method.
కూలింగ్ ఆర్క్ మెథడ్ అది ఎక్కడ ఉన్నాం?
High resistance arc.
హై రెసిస్టెన్స్ మెథడ్.
In
So there are two methods. One is high resistance method and low resistance method or current zero method. Okay. So here in case of high resistance method, the arc current is forcibly reduced to zero. And the arc current is forcefully zero by increasing the resistance of the arc. Arc resistance increase చేస్తే zero reduce చేయొచ్చు. So by using this, you can implement for both AC and DC. But it is preferred for breaking DC currents only. Why? Because if you want to increase the arc resistance, the spacing between the contacts has to be increased. Because if you want to increase the length of arc, spacing between the contacts has to be increased. Size of the circuit breaker becomes large. So, but in case of AC current, if you observe, natural current 0 points are available. Okay, naturally current 0 points are available. That's why we prefer what high resistance method for breaking DC currents only. అర్థమైందమ్మా?
Okay, sir, but cooling the arc length, increase the length of arc.
Cooling the how you can increase the resistance of the arc means. So if you increase the length, arc resistance increases. If you decrease the area of cross section, arc resistance increases. Okay. So here you are increasing the length of arc. Next I have shown increasing the resistance of arc by decreasing the area of cross section. Once you apply high pressure cool air, what happens? Arc stretches like this. So its area, whenever you stretch the arc, what happens? Area of cross section reduces, length increases. And cooling of arc, whenever you cool the arc, heat will be dissipated. No, heat dissipation takes place. Okay, splitting the arc. Once you split the arc, automatically resistance increases. Constraining the arc means you are not allowing the arc to continue. Okay.
Like constraining the arc.
కన్స్ట్రైనింగ్ అంటే ఆర్క్ ని అలౌ చేయట్లేదు. ఇప్పుడు ఇక్కడ చూడండి, ఫస్ట్ ఇంక్రీజ్ చేసినాం, హై ప్రెషర్ కూల్ ఎయిర్ అప్లై చేసినాం, కూల్ చేసాం, లెంత్ ఇంక్రీజ్ చేసినాం, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ రెడ్యూస్ చేసినాం, ఇక్కడ ఆర్క్ స్ప్లిటర్స్ యూజ్ చేసి స్ప్లిట్ చేసేసినాం. ఇంకా ఆర్క్ కన్స్ట్రైన్ చేసినాం అంటాం. కన్స్ట్రైన్ అంటే అలౌ చేయట్లేదు అని. ఓకే
ఓకే సార్, థ్యాంక్ యూ సార్.
So we'll stop here. If others are having any doubts, we can mail to me.